Hey everybody, DJ Cozy's my name, and I rock the microphone, and I'm fame. I'm easy to grow and rock the mic. Yeah. What's up, yo? Check the flavor. Yeah. For a few euros more, I can hold you in the sky. For a few euros more, I can look into your eyes. For a few euros more, I can hold you in the sky. For a few
mic working? Yes. Hi, welcome to TOA 2016, day 2. We got to listen to a lot of amazing speakers yesterday, and we have a lot of amazing speakers today, starting with Serkan Piantino. He's the former lead of Facebook AI, and he's going to be telling us about new capabilities with neural networks. Welcome, Serkan.
Thank you. Hello? Hello? Hi. Is everyone awake? Okay, good, because we're going to learn some things. There's some math involved, so I hope we're all prepared. I'm Serkan Piantino, and I want to talk about things that we can do now, primarily with neural networks, that we could not do with computers 5 years ago. And as we mentioned, most recently, I was at Facebook, and I founded Facebook New York, and was co-director of Facebook AI Research with Jan LeCun, our Facebook's AI Research Lab. So before we get into AI, I want to talk about something called machine learning. And machine learning is really the sort of like math basis behind all the things we're going to talk about. So it'll be useful to do a review here. First, what is machine learning? Well, let's say we have some function that we want to compute, something, but we don't really know anything about it. We have no idea what the function might look like. But what we do have is a bunch of examples of inputs and outputs to the function. And so what we want to do is learn some approximation that might fit the data we have and approximate the function. So that's sort of difficult. I have a little demo here of what this might look like. Here, this line in green is a function that we want to learn. And this line in blue is increasingly using data that it's sampling from the function, modifying itself to better approximate the function in green. You can see it kind of jiggles around a little bit. It takes some time. But eventually, it goes from being a really poor approximation of the function in green to being actually a quite good approximation. And here you can see it nails it pretty well. So that's what we want to do. We want to learn approximations of functions from data, which seems very abstract. But I want to point out that functions really can be anything, including things in the real world. So for instance, you interact with everyday services like Facebook or Google. Behind the scenes there's a function that we are trying to compute that's predicting whether or not you're going to click on either an ad or a piece of newsfeed content. And that is really a function where the inputs are all the things we know about you and what you like, et cetera. And the output is the probability that you click on that piece of content. Object detection. This is one of the things that we can do now. We can look at a scene, for instance, this one, and we can say, oh, this is an auditorium. This is a person sitting. These are slides. This is a computer. That type of thing. And so for object detection, this is the same type of function. The inputs are all of the pixels that I might have in a photo of this room, and the output would be the label for the image. Q&A. You've seen a lot of text bots, a lot of things that encourage you to make dialogue with AI agents. These are also functions. The inputs are the sequence of things that you've said to the bot, perhaps some history and context about who you are. And the output would be the answer to the question that you asked. And then finally, if I really wanted to really take this to the extreme, life is a function. You know, all of the inputs to all of my senses up until now are the inputs, and the outputs are the signals that I send to my hands and to my voice and the things that I choose to do. So you really can think of anything where you have to make a decision and inputs come in and outputs go out as a function. And so we can apply machine learning to all of these more human problems as well. And what's happened in the past couple of years is exactly what I described before, happening much faster. So nowadays we have more data because we all live our lives online, and we have services like Facebook and Google and all the other things that we use that can accumulate all of this human data about people that we can analyze. So we have more data to build our approximations. We have faster training. Technology has improved. The software and hardware that we use to do the computation that makes us train these models is much better than it was just a couple years ago. And we have more powerful models. Neural networks, something that I'll give you kind of a brief overview about them, are capable of learning all types of really complicated functions. They can make use of lots of data, and they're really showing a lot of impressive results. So you put those things together, and what you get are capabilities that we can explore with computers that we couldn't just a few years ago. So let's dive in. What is a neural network? What does that mean? Well, it's actually not that complicated, and I'm going to jump into it. Here, in this figure, you can see on A, that is a typical neuron in the brain. A typical brain will have about 100 billion of these all wired up and interconnected. And you can see on the left it has this cell structure, and it has these things called dendrites. And the dendrites can be stimulated. That's when they receive signals, they get a little excited. And they come together, and if all the dendrites, if the sum of the stimulation on that neuron exceeds some threshold value, then you'll have an electrical impulse travels along the right side of this neuron, down the axon, and out the end of a neuron. And that's what we call a neuron firing. And so in figure B, we have the artificial version of this, the thing that we might use in a computer. And it has the same structure. It has these inputs, X, which you can think of as kind of the stimulation on the dendrites of the biological neuron. They come together, and there's some activation function, F, where if all of the inputs to the neuron exceed some threshold, then an output comes out the side, Y. And these have been, artificial neurons like this have been explored for a long time, and it's only recently that we're able to make use of them and train them to do interesting things. In figure C, you see that these neurons can be interconnected. In your brain, all of the neurons can be wired up to all of the other neurons. And while there are about 100 billion neurons themselves, these points where one neuron is connected to another, there are something like 100 trillion of those in the brain. So the points at which things can connect, these things called synapses that really kind of encode who you are and how the brain works, there's a lot of them in a human brain. But we can do the same thing for artificial neurons. We can wire them up so they stack on top of each other. The output of one becomes the input to another. And we have the same sort of analog to synapses in the computer. And this is an artificial neural network. And this is the sort of relatively simple explanation, but the artificial neural network is kind of the key workhorse behind all of the things that you hear about, all the advances in AI that you'll hear about today and in the press and in the media. So hopefully that makes sense. Let's talk about some things that you can do with this type of technology. The first general domain is in visual perception. And so that's something we take for granted. We can look at a scene and we immediately understand what's going on. But computers have struggled with this. In fact, we are so sure that computers can't do visual perception tasks that we use them to make sure that you're not a robot. If you've ever filled out one of these CAPTCHAs, that's exactly the concept here, is that the computer can't read the image. And in fact, yesterday, if you came to the talk, the CAPTCHA project was my undergraduate research, and my undergraduate research advisor was Luis von Ahn, who gave, I believe, the keynote yesterday. So good continuity in the programming here. So traditionally, the way you would have solved a problem like this is you would have built these things called feature extractors. You would have tried to figure out, well, maybe we can detect some edges in the image. Maybe we could figure out what cars look like. Maybe we could detect a circle and then figure out if there's a rectangle on top of it. And maybe that would be a good signal that then we use some machine learning. We do some sort of classifier on top of that. And maybe we can figure out if this is a car or not. That's the sort of traditional technique. These days, with neural networks, what we do is we feed every pixel of the image in, and we use a stack of these neural network sort of models on top of each other, and then only at the end we get a label, and we train everything end to end, which sounds sort of vague, but I'll give you an example of how it works. This is sort of some internet archaeology. This is one of the first convolutional neural networks. This is being used to do handwriting recognition. And there was a time in the 1990s or 1980s where this network, the first convolutional neural network, was reading about 50% of all the checks written in the US. So this was one of the first applications of this technology, detecting handwriting and printed digits pretty well. And you can see the man operating this computer a very long time ago is Yann LeCun, who was my co-director at Facebook AI Research. So these, to give you a sense of the structure of this network and how it works, it's looking at this image and it's applying filters over it. So it's got these filters that look for patterns, and it tracks where those patterns appear in the image and then creates some new images that represent those. Then it passes some filters over those and so on and so forth until it's whittled the image down to a small set of factors that it can then make a decision about. Here's a visualization of how it works. So in the middle you have the input image, on the left column, you see the output of the first set of filters, and you can see they're doing relatively basic things. They're sort of looking at edges and contrast. You can see the output in the second column of the second set of images. You can see things are getting a bit more abstract. The network is sort of processing its input a little bit more. In the third set of images, you have the outputs of the final layer, and those are pretty indecipherable. You can't really tell what the network is learning there. And then finally, you have the prediction. So basically, the network is doing some very basic visual processing, building some abstract layers on top of that, and so on and so forth until it learns end-to-end, from top to bottom, how to build a model of turning the pixels in this image into the number that it represents. So don't worry if you don't follow all of that. It's not that important that you understand. I just thought it was useful to go into the technical details here. And what we do now is we can do the same type of thing. If you saw the old computer in that video, it was quite out of date. These days, we do this type of work on things like this. This is one of the Big Sur servers that we developed at Facebook. It has 8 GPUs, all from NVIDIA. And to give you a sense, Deep Blue, which was the supercomputer that beat Garry Kasparov in chess so famously, that was a 96 gigaflop machine. This is a 56,000 gigaflop machine, so roughly 1,000 times faster than the supercomputers that dominated not too long ago. So visual perception is something we can do, and we have lots of applications for this. So you're all familiar with facial recognition. This is powered by neural networks. We can tell who people are. In fact, the state of the art in face recognition these days is far, far beyond what we would consider human performance. We can also, there we go. We can also label images. So in the top, this is just a stream of images coming into Facebook servers. At the top are all the ones that contain fireworks. Actually, these are videos. In the middle are all the ones that are labeled with food and are about food. And on the bottom are all the ones of cats, because you cannot talk about the internet without somehow mentioning cats. It seems to be the rule. We also can do things like this. So this is plugging in all of the pixels of an image and then asking the network to label each pixel with what it is of. And this might be useful if you wanted to teach a car to drive. So here you can see it can label which parts of the image are the road, which parts are other vehicles, which parts are pedestrians, buildings, sky, that type of thing. And this type of technology is literally running, if you are lucky enough to own a Tesla, there's a small chip that is running basically this type of network whenever you turn on autopilot. We also have gone beyond being able to label just one image and what it's of to being able to label individual objects and actually segment them. This is from a pretty recent competition from MSR and a couple of other places called COCO. And it requires a neural network label all of the objects in the image and provide these little sort of coloring ins of the image. And this is something that was, again, not even close to possible just 2 years ago, and now is kind of the cutting edge, and we're seeing close to human performance on this type of task as well. And then I saw, actually, this was just a couple weeks ago, I saw on Hacker News, this was a network someone threw together. They pulled some code off of GitHub that inputs black and white images and then learns how to color them in. So here you can see on the left, you have black and white images. On the right, you have the actual colored images that they started from. And then in the middle is the guess that the network provided. And you can see it learns some pretty interesting things. It learns that skies are blue. It learns that grass is green, water is blue. It kind of learns this like vague tone for human skin. I'm not totally sure why, but even something like this is something that people are doing sort of in their spare time, and again, wouldn't have been possible just a couple years ago. So that's all in the domain of visual understanding. Let's talk about language, or what I usually call symbolic understanding. And to do that, I'm going to need to complicate our model for neural networks a little bit. On the left here, we have a traditional neural network. This is really simple. You have some neurons. Their inputs flow up to this second layer of neurons, and then so on and so forth through these 3 layers. Pretty straightforward. On the right, we introduce this squiggly concept here, this idea that the output of one neuron is going to flow back into itself. And what that means is that when we run this network, the second time that we run it, we will include in the inputs for that node in the middle the previous output of that node as one of the inputs for the next run. So that basically means the previous run, some of the state from the previous run is getting fed back in, and some of the context is being preserved across runs for this network. And this turns out to be hugely, hugely important and powerful. Brains themselves are mostly these sort of recurrent connections where things go backwards in the network instead of forward. And one really interesting way of thinking about this is that in a traditional network, you're learning a function. You have some inputs, and they go through the network, and then you get some prediction of the outputs. But with a recurrent network, because this state is preserved, we can learn all types of full programs. So the dialogue agent that I talked about in the past, a good thing to do might be to preserve some of the state throughout the dialogue, so I know that when you use prepositions, who you're referring to, or if you know, if we have a dialogue about booking a venue, I don't have to ask you the details of it every time over and over. So you can see we can learn all types of functions that that are really full programs and preserve state across different things. This turns out to be really important in language because even just a simple sentence can have all types of crazy structure that's, you know, sort of not quite as straightforward as we usually think about it. Even a sentence like this, if we try to parse this one sentence, you can see all the interrelationships between adjectives and verbs and subjects and nouns. You get this pretty complicated tree. And so learning a program that can input a sentence, remember some of the state in the past, and really understand it is one of the advances that we have in AI these days. So here's a couple demos of this technology. First, this is my favorite. This is a network that was trained to learn this pattern of its inputs on Shakespearean text. And then we can turn the network over and we can make it generate completely synthetic Shakespeare, and this is what it comes up with. Actually pretty convincing Shakespeare, I would say. You know, it even gets the different characters, it gets the tense, it's roughly getting iambic pentameter, pretty impressive stuff. We did the same thing, training a network on a corpus of text and then having it generate synthetic examples of it on Facebook posts, and we got much funnier results. So here's a bunch of random Facebook posts completely synthetically generated. You can see it understands some things. You know, it gets some of the structure, but it really doesn't understand the world quite as well. My favorite is I have an urgent Candy Crush exam, which is not something that people would, but you can see it really understands, you know, that urgent is about exam, and Candy Crush is something people do in class, but it doesn't quite understand why those might not work together. And so we, you know, working toward dialogue systems, this idea that we can all interact with chatbots and stuff is something we spent a lot of time working on. Here's a system that uses recurrent networks to read a story, in this case, a relatively much simplified version of The Lord of the Rings. If you haven't seen The Lord of the Rings or read the books, you know, avert your eyes because there are spoilers involved here. But the network can then take questions and answer, remember the context from the text that it read, and then answer questions about it. So this is something we call baby text. And then finally, sort of combining the stuff that we learned on, in visual perception and combining that with this symbolic understanding, we can build these networks that on one side process the pixels, but then go through one of these language generation networks and kind of staple these two techniques together, and we can plug in pixels and generate captions for text. So you can see this is actually you know, trained on what people might actually caption this photo with. This is actually quite good, this photo. The caption here is a group of people standing, shopping at an outdoor market. There are many vegetables at the fruit stands. Pretty convincing. And of course, this is something that we deployed to make it a little bit easier for our blind users to understand the stuff that was scrolling through a newsfeed. So if this, not sure why it's not playing, but this is a demo of a blind user being able to understand everything that's going on their newsfeed, whereas in the past they couldn't see any of the photos. So the final thing that I want to talk about is a little more abstract. It's about learning representations, and this is something that we call embedding, which is actually a little complicated to describe, but is actually really fundamental to how human beings understand the world. And it's important to realize that we don't remember every pixel of the world that we see, right? We don't remember every detail, but we do remember high-level themes. So we remember representations in our brain. Somewhere in there is stored, you know, the faces of our friends and the fact that some of our friends, you know, like playing chess and some of them don't. You know, all these sort of higher order memories are stored. So how can we generate these higher order memories? How can we generate a representation from the world that's compact and a summary of the things that we want, but is also useful? And so that's what this technique that I'm going to talk about, embedding, lets us do. It lets us take high-dimensional stuff, like a photo of this entire room, and then create a mapping where we can move that into a different space where it's smaller, but also has a bunch of useful structure in it that we can use to make decisions in the past. So, and we can do that because we can use connection and similarity. We understand, we have enough data to tell us which things are similar and which things are separate, so we can use that as training for our model. So it's very abstract, hard to understand. Here is an embedding model built on Instagram photos. And this uses its knowledge of what Instagram photos are more similar to then train a visual network to understand what's in photos, and then uses that to group photos that are similar together in ways that we couldn't do in the past. So here, this is in the embedding model, this is the sort of kitten region. Down here, you can see it's grouping all the dogs and the puppies together. And then now, if you visualize over here, it's all the things that are food together, even if they don't quite look the same. It understands the difference between different types of food. This is the sort of flower region, et cetera. Things like that. So this is kind of grouping things together and exploring what things are similar and what things should be grouped together, more in the way we would think about it than in the way a computer might traditionally think about it. And so we can do the same thing for words. This is a very common model that you can play around with, very easy to run, called Word2Vec. And what it does is it builds these representations that I talked about. It builds that sort of embedding space before out of words. So here you can see that if we plug in, this is if we plug in these are all the most similar words to Sweden. You can see it understands Norway, Denmark, and Finland. It's all the countries that are similar to Sweden. But it also understands all of this other structure. So here, if we train the exact same model in English, and then we train it on Spanish, and then we map out where the words end up, you can see that on the left is a map of where the words end up in English, and on the right in Spanish, and you can see the structures are roughly the same. It sort of understands that the relationship between 1, 2, 3, 4, and 5 is the same in both of these languages, and the relationship between cat, horse, cow, pig, dog is the same in both languages. And it even gets all these more interesting relationships. So you can ask it to do these sort of word associations, just like you might see on the SAT, or for those of you that are from the States. So if you ask it, king is to queen, as man is to, it gets woman. So it understands these sort of gender relationships. China is to Taiwan, as Russia is to Ukraine. It understands these sort of geopolitical tensions. Knee is to leg, as elbow is to forearm. It's pretty good at anatomy as well. And even crazy things, Donald Trump is to Republican, as Barack Obama is to Democrat. It understands current events, things like that. Just from feeding it a corpus of text and asking it to build these representations, we've captured all of this structure of language that we use. And we can do the same thing for images. So this is a network that builds these representations of images and then creates completely synthetic images out of the space that it generates. So here, these are different completely fictional bedrooms at relatively low resolution. But you can see they're pretty plausible images that would confuse a person about whether or not they were bedrooms. This is the same thing to prove that they're synthetic. This is smoothly walking from one bedroom to another, and at each point generating a new synthetic bedroom. And you can see the windows morph into beds and doors and televisions and things like that. So it really is sort of understanding what makes a bedroom a bedroom. And then some even more interesting stuff, just as we can do arithmetic on these representations we learned of words, we can do the same for faces. So these are synthetic faces. On the left are a bunch of faces of men wearing glasses. We take the inputs that generate those and we average them. In the middle are a bunch of inputs of men without wearing glasses, so we take the inputs there and average them. We subtract them and then add in this vector that represents women without glasses, and sure enough, it puts you right in the space, right in the area of the space that is images of women that are wearing glasses. So there's all types of structure that these spaces can understand about the world that's sort of more similar to the way we might understand things than storing things as raw pixels. And then finally, I thought there were some fun applications of this. This is totally synthetic manga characters from anime series. These are totally synthetic. This is one of my favorites. These are totally synthetic album covers. So if you have a band and you don't feel like designing an album cover, talk to me after the talk. We can make one up for you. And just all types of things that we can now generate because we understand the space, the sort of semantic space that things might fit in the same way that people do. We can ask computers to do all types of things. So that's about it. I want to leave you with the final point. If you had to learn one thing today, what would you learn? Well, it's that these days, there's a lot more data in the world that represents how humans understand the world. We have faster training because we've evolved the software. We have really fancy hardware. We have all types of things that let us train on humongous amounts of data in relatively short amounts of time. And we have these powerful models that are mostly empowered by advances in neural networks. We understand and we're able to bring to bear. And so with that, with these three things, there are many new things that we can do now that we could not do 5 years ago. So thank you, Berlin.
Difficulties. I'll be right with you. Thank you so much, Serkan. We're experiencing a few tiny little technical difficulties. So we will be continuing in about 10 minutes, maybe 5. Let's see how well our tech works again. But yeah, stay tuned. And next we have Rodrigo Nino. And yeah, give us like 5 to 10 minutes. Thanks. right, we've gotten our technical difficulties back in line, so we're back with Rodrigo Nino. Rodrigo Nino is the CEO of Prodigy Network, and he's going to be telling us today about crowdfunding a skyscraper, the future of financing and investing. Thank you.
Thank you very much. Can everybody hear me okay? Yeah, okay, very good. So, let's start 80 years ago, a little bit over 80 years ago. Right after the worst of the Great Depression in 1933, President Franklin Delano Roosevelt realized that fraud was huge in the preceding crisis, in the Great Depression. And he decided to create a law that he called the Securities Act. And in that law, he effectively decided that the people, the crowd, could invest in public offerings. That whomever decided to present something to the public, they had to register to precisely prevent the fraud that I just mentioned before. So everybody had access to public offerings, provided that they were duly registered. But he also created something else. He created private offerings. And in the private offerings that were exclusions or exceptions, he decided that only a selected group of individuals that the law calls accredited investors, which is a fancy name for the very rich, only those accredited investors or very rich people could invest in private offerings. So in reality, with the argument of protecting the public from fraud, he created legally a form of separation, a form of exclusion, because you had the public offering, and picture that this crowd here is the public, and everybody has access to the public offerings, but only you guys over here have access to the private offerings. So that immediately was established as the separation, as a delusion of separation. And that delusion of separation was really part of a dreamlike reality that we are all living in, with that, again, cornerstone of the delusion of separation that we call capitalism. So in capitalism, the individual is really what matters. It is the thesis of I am because you are not. It is the zero-sum game. It is what gave birth to Occupy Wall Street movement. It is the basis of the system as we know it today. And it has a legal footing based on the Securities Act. With that in mind, after 80 years, we realized that the big conclusion of that system, well, it generated incredible growth from feudalism through capitalism. It also concentrated incredible amounts of money in the very few that had access to these private offerings as well. And that was the basis of inequality, which is the most pervasive problem, of our current system. And then the response to that, the natural reaction to that delusion of separation is communism or dystopic socialism, which is even worse than capitalism itself, because there cannot be a crowd, a happy crowd of unhappy individuals. That just doesn't work. Communism and dystopic socialism compromises human spirit. It undermines creativity. It promotes corruption and laziness. And we end up, in systems that, quite frankly, don't grow and that really kills human spirit altogether. So that system of capitalism and that delusion of separation as part of that dreamlike reality, with the antagonistic approach of socialism, dystopic socialism, and communism, ended up in the second worst crisis that we have seen after the Great Depression in 2007 that we deemed calling the Great Recession. So in the Great Recession, what happened was that it was very obvious and evident that the wealth destruction that the public market in Wall Street entailed didn't happen as much in the private offerings. And that wealth was preserved in the private offerings. So effectively, the people, which were the very, very wealthy, that had access to the private offerings, didn't lose as much money as the ones that only had access to the public market. And exactly like what happened after the crisis of 1933, then after the crisis of 2007, another law was created to respond to the underlying problem of inequality in the same fashion that the Securities Act responded to the problem of fraud in 1933. But here, you know, it was called the Jobs Act. So President Obama, as a reaction to that mounting evidence of how wealth was concentrated based on private offerings and how people didn't enjoy the protection that the very wealthy did enjoy in that crisis, created the Jobs Act. And in that law, if we go back to capitalism, as explained over there, what he did was that he eliminated the VIP. He eliminated the restriction that the public had to access private offerings. And the system looks now something like this, where effectively you have the paradigm of access for all. So now there is no separation and everybody can access the former private offerings. So let's think about this for a minute. So we're shifting from an exclusion system with that delusion of separation into something that is really access for all. And that is extremely, extremely powerful. The problem is that that access for all was deemed crowdfunding. And by calling it crowdfunding, we associated it immediately with the financing of iPhone gadgets, because that's what we think it is today, when in fact crowdfunding is something much different. Crowdfunding can be used to fund large-scale projects that really, really matter. So if we have a former private offering that is right now available to the public like never before, we have a contradiction, because you cannot have a private offering that is public. That is just, that doesn't work. What you really have is a new public offering. And if you put one public offering of that kind next to the other one, then you have a new public market. So in the same fashion that we had Wall Street before, as a conclusion of the Securities Act, and as a response to the Great Depression, we now have this new public market as a conclusion of the Jobs Act and as a response to the Great Recession. And that one is based on access for all, like we said before. So to understand it better, let's brand it, like we like doing in the United States. So if the previous one was called Wall Street, let's for argument's sake call this one John Street, like another street, just to pick a name. So what happens in John Street? What happens in that version of the new public market? The first thing that you can do is, because you have access for all, you can buy buildings like that. Those type of buildings, which is one we bought with a crowd of people from 25 countries and 22 different states, was one of the commercial real estate in Manhattan in particular, is one of the biggest enclaves of wealth concentration that we inherited from the previous system. So now we have access to those type of assets. So the first thing that we gotta learn about John Street is that it can finance large-scale projects. So you need to get away from the notion that crowdfunding is for smaller enterprises. We are on our 7th building. I'm originally from Colombia, but I've been living in the States for 20 years. And in New York, we have 5 buildings, and in Colombia, we did crowdfunding for 3 buildings. The combined portfolio is over $1 billion, We have raised over $400 million in common equity, like I said before, in 25 countries and 22 different states. And we have been working with different institutional lenders as well. So there is cooperation as opposed to an antagonistic approach. So the first thing to learn is that crowdfunding or John Street can fund large-scale projects and potentially destroy enclaves of wealth concentration, which is the second important thing or important takeaway or lesson to learn. In John Street, let's analyze this, because we believe that John Street can be the end of inequality itself, which is the pervasive problem from our system. Now, let's assume that Peter, Paul, and Mary, they are three investors, and each of them invests $1, the same dollar in appearance, okay? So, in reality, while you would expect that they get the same return for their dollar, Peter gets 22 cents, Paul gets 8 cents, and Mary gets 2 cents return with the same dollar. So why that disparity when it was the same dollar they invested? Now, the answer is twofold. First, Peter has $1 billion of net worth, Paul has $1 million of net worth, and Mary has only $1,000 of net worth. So Peter, you would think, okay, he has the money. He has access to the larger opportunities, the ones with the better returns. But in fact, what they had is the protection of the private offerings, typical of capitalism, where only legally he could invest in those offerings, because until 2013, with the creation of the Jobs Act, Paul and Mary couldn't invest in the private offerings because they were being protected from fraud. So now, thanks to the Jobs Act, Paul and Mary can pull together and have access to the opportunities that only the Peters and friends of the world had before. So now, the value of each dollar is not relative to the amount of wealth each individual previously had. Because we, in the world of capitalism, may think that each dollar has the same value, but it is not true. Because it truly depends, the return on each dollar and the value of each dollar, on the amount of wealth you previously had. But thanks to the Jobs Act in John Street, now Peter, Paul, and Mary have access to the same opportunities because they can pull together through technology and invest in those assets that only the very wealthy had before. And that, in our mind, could be the end of inequality. Now, the third lesson to learn is that crowdfunding, or John Street, is about community, even more important than inequality. Let me give you an example. We have a friend in Chile, and he's interested in replacing traditional energy generating sources that are not necessarily very good, as we know, for the environment. So he's interested in biomass, and he's an entrepreneur, and he knows everything about biomass. And he knows how to build a plant that costs $60 million, that obviously he doesn't have, but he has the knowledge, that could potentially provide energy for a city of over 500,000 people. Now, again, he has the knowledge, he can build this plant, but he lacks the money. And the cost of the plant is $60 million. Now, the plant can be sold to a distributor of energy for $100 million with a profit of $40 million. Now, with that in mind, let's understand and make a comparison between Wall Street and John Street. $60 million is the cost, $40 million is the profit, and $100 million is the sellout. In Wall Street, what happens is that because the private equity fund, call it Peter, is the one putting the $60 million, he's entitled to receive, say, $38 million of the $40 million of profit. He would leave only $2 million of profit for the entrepreneur, who should be happy because he didn't put any money down. You know, it doesn't matter, you know, that he had all the knowledge and the experience to put it together. So they split the pie, $38 million to the private equity putting, the $60 million cost, $2 million to the entrepreneur with the great idea and nothing to the crowd of 500,000 people that are going to be consuming the energy in the city. Now, in John Street, here is how it works. The entrepreneur turns around and he talks to the 500,000 people. And he tells them, guys, we need an energy plant. We are going to benefit of that. It costs $60 million. Why don't you invest the $60 million through a crowdfunding platform based in energy, and we can split the $40 million as follows. You can take half of the profit, say $20 million. So the 500,000 people that are consuming the energy are going to get 50% of the return, which is the $20 million. And he will go from $2 million in Wall Street to $10 million in John Street. And the private equity fund is going to be replaced by the crowdfunding platform like us, but in energy, and make $10 million. So if you put it side by side, you will have the private equity in Wall Street going from $38 million down to $10 million in the crowdfunding scheme in John Street. You will have the entrepreneur going from $2 million to $10 million if he decides to do it in John Street. And the crowd, which is the most important thing, will go from 0 to making 50% of the return with $20 million in profit. And that really changes everything and shows you the differences between Wall Street and John Street. Now, what is the underlying formula or the underlying conclusion that stems of this in terms of community creation? That the people are investing in the solution of their own problems and that they're doing it for a profit. That's the big difference between John Street and Wall Street. Now, like we say, the unique value of crowdfunding is not money, it's the community. And let me give you another example, because you have seen commercial real estate wealth concentration, and how it can be disrupted in John Street by providing access and smaller investors to opportunities that they didn't have before. We see also how people can invest in the solution of their problems, through investing in energy plants. Picture the possibilities of John Street. Picture everything that can be done over there. Let me give you a final example that is very close to my heart, just to illustrate the power of John Street and the potential it has. Right now, like we said before, capitalism is a dreamlike reality with the delusion of separation amongst individuals. It is a fake version of reality that effectively is entrapping us into that individualistic approach, into that zero-sum game. Now, there are scientists working in groundbreaking research, with a certain compound called psilocybin, which is a psychedelic. There are many other psychedelics, but these guys are focused on psilocybin. And they have seen how psilocybin agonizes or stimulates the 2A receptor in serotonin in the brain. And by doing that, it has potential of curing underlying mental diseases like end-of-life anxiety that I suffered of when I was diagnosed with stage 3 melanoma 5 years ago, which is a terrible fright of dying. It can potentially cure the end-of-life anxiety. But it can also cure, potentially, other diseases that are associated with the 2A receptor, like depression, monolytic, treatment-resistant depression, and alcoholism as well, and other addictions, like cocaine addiction or heroin addiction. But it can also cure, potentially, trauma, typical trauma, or PTSD, or eating disorders, like anorexia, or even OCD. It can really be a mental health revolution. Dr. Nutt in the Imperial College of London says that this is to neuroscience what the Higgs boson was to particle physics. It is that important. Now, if we put that incredible work that these scientists are doing, and we need to fund the research that they are doing to complete these studies and really answer the questions that matter most. The discussion is about medicalization. The discussion is never about legalization. We need to know if this is addictive. We need to know if what we have been led to believe in this dreamlike reality about these plants is truly what it is, or if it is not. We need to know if they can potentially cure these terrible diseases. And for that, research has to be done. And that research is being done by NYU, Johns Hopkins, the Imperial College of London, the University in Zurich. And the research is duly approved and fully legal by the FDA and by the DEA. But now these guys, to complete their studies in all those universities with the potential that it has for positive impact in mankind, cannot be funded in Wall Street. Why? Because there's a huge misalignment between return on capital and the potential impact it entails. And here is the underlying problem. These substances, okay, deemed psychedelics, are natural compounds that cannot be patented. They cannot be patented. So they are terrible money makers. And the second thing that happens is that they can not only be patented, but they can potentially cure with only 2 takes. So somebody with treatment-resistant depression takes 2 times over 9 months any of these compounds, and they can be cured from depression. So what that means is that Zoloft, Xanax, Prozac, and so on, that are treatment-based medicines, nor cure-driven medicines, are going to be in big trouble. So the traditional equity providers for this type of research are the institutional pharmaceuticals. And they have no interest in doing that, obviously. And who can blame them? It's not their fault. Picture the CEO of a pharmaceutical going to the board of directors saying, listen guys, let's fund the research, for these substances that can't end depression. And the board of directors is going to say, what are the implications of that? That we're going to stop selling product, therefore stop making money. Now, if we take the work that these guys are doing and we put it in the context of John Street, or what we call crowdfunding, and we picture that this is the world population right here, I would effectively tell you right now with a microphone, guys, we understand these other folks that don't want to fund this work. It's natural. However, we can do something about it. And the families of the patients, and the patients themselves, and the friends of the patients can effectively come in John Street and fund the work through technology that the institutional investors don't want to, because obviously there's that misalignment between return and positive impact. So that shows you how community, large scale, and alignment of profit and impact is the new Wall Street, and we call it John Street. And just the final thought to wrap up, the thing that inspires me most is not only the mental health revolution, but the byproduct that comes through it. Because we understand the mental health revolution to be a stepping stone into what we call the collective conscious evolution. Because we really think that the dreamlike reality with the delusion of separation that we call capitalism, that we are all part of right now, we can get out of it into something where the impact on the positive impact on the crowd is lined up with the individual self-interest, away from communism or dystopic socialism. It is going to be doing well by doing good. It is going to be I am because you are. So we can crowdfund our way through a collective conscious evolution and fund ourselves out of that delusion of separation, so that we can truly be a global community in the future. Thank you very much.
Thanks so much, Rodrigo, man. Great talk. Inspiring story, man. All right, and we come from the last slide of psychedelics and Rodrigo, talking about collective consciousness to Burning Man. And that is, of course, in no way correlated. Very excited to welcome my next guest, Bear Kitty. He's a former tech entrepreneur, founder of canvassing tool organizer.com, also built a platform for music. And he's been involved with Burning Man for a few years. He was a global ambassador, literally going to every single Burning Man in the world, in all these other locations that they also pop up and happen. And he's now most recently been involved with a revolutionary new project by Burning Man that, just like Burning Man, will surely impact the way the communities are being built around the world. Give a big hand to Bear Kitty. Thank you.
All right, can you hear me? There we go. Beautiful space. This feels like an altar. It's so lovely to be here in Berlin with all of you. People often say Berlin is like Burning Man all the time, you know. It certainly feels that way. We're gonna try a little unique experiment here. I have Nate up there in the corner with a didgeridoo and an Ableton push. So we're gonna have some improvised musical soundscapes for this. So Nate, you wanna kick that off? Yeah. So yeah, just starting, here we are at this conference. Let's just try to drop into ourselves. A lot of big cerebral ideas. Can only do so much with that unless we really drop in. So just take a moment with yourself. And imagine the vision of the world that you want to live in, that you want to co-create. Because that's where it starts. It starts with that seed, with that vision. So, how did we get here? We have a lot of questions to ask right now in our current world. How are we going to build a culture that can truly allow our world to be, much as the speaker before me talked about, to remove that illusion of separateness, to remove these incentives in our competitive culture that ultimately cause us misery and misalignment? Well, perhaps having these physical spaces where we can actually go and reimagine what our culture is, where we can prototype the design of our new civilization, is really important. I think that, in a way, that's what we're doing here. These conferences, these ephemeral experiences, these festivals that we design, that we go and we experience these immersive ways of life, and we reimagine who we are, what's most important to us, how we should be allocating our resources through experimentation, through art, through participatory culture. And what is that difference between coming in, me on this stage, you all out there, sort of this consumption experience, versus truly something that is participatory, that is co-created, that isn't locked into that safe model? That's really what makes Burning Man magical. It started as an experiment on the beach. A man burns, a group of people come together to witness this ritual, to reinvent a ritual. And it grows, a couple hundred people, moves from the city to the desert, this annual pilgrimage. And it grows. People come and they build big art sculptures. They come and bring their friends and build theme camps, different identities, different tribes. People come and they take this culture and they forge this cauldron of experience and they bring it home and they reimagine it. Don't cue the video yet, please. Not yet. Start with the image. And it grows over time, year by year, because there's this blank canvas that can't stay the same. It's not about creating a permanent piece of infrastructure. It's about reimagining every single year and letting go of what was built. And year after year after year, we now have Black Rock City. You can cue the image. 70,000 people living in this temporary city, prototyping the future of our civilization. And yet, it's become harder and harder to enter into that experience, because how will it truly be transformative if it's just for the people who are lucky or privileged or in the know enough to be there? If it's the Willy Wonka golden ticket to some utopian thing, how will that truly make a big impact in this world? So that's where we've been. Black Rock City now has reached its capacity of 70,000 people, and for the current moment cannot grow. So all over the world, people from places like Berlin, Japan, Korea, South Africa, Sweden, Israel, Denmark, people have been coming to Burning Man, coming home, finding locations where they can start a similar environment. So these events now have grown. There's over 60 all around the world, multi-day events that take the same ethos of participatory culture with no money, with no trash cans, with really no predictive event structure, and come together and experiment with building community. The same problem. How do you scale this environment? How do you grow it without losing and diluting what is most fundamental to the experience? These are replicating. But after traveling the world and learning from so many of the burners and so many of the different types of festivals and civic experiments that are happening in many different disciplines, it became really clear to us a next step needed to happen in order to up-level this entire movement so that we could move more from these ephemeral experiments, these utopian dreams, cooking this new culture in that sort of peak state. How do we get to actually radically transforming the infrastructure of our civilization? Well, it's beautiful that we have intentional communities and these ways of living that people, if they're lucky enough, can live in this different way and experience so many of the benefits of that culture year-round. But maybe between these temporary experiences and these permanent intentional communities, maybe there's a step in between that's fundamental to allowing our whole world to be included in the process of moving forth. So that was 2.5 years ago when we decided together to start the project that was sort of a prophecy of the Burning Man vision. It was where the event was held in 1997. And just last month, we completed the acquisition of Fly Ranch. Fly Ranch, the overall valley, is roughly the size of Manhattan, 20 square miles. Our property is 3,800 acres. It includes beautiful hot springs, hot lakes that hundreds can swim in, and geysers, and a very, very large playa, this open tabula rasa, this context for reimagining our civilization. So now we own this property year-round in the nonprofit organization. It's really a gift for the community, by the community. It's been funded completely philanthropically by a group of patrons who believe that the process of us coming together as a community and experimenting with what could happen there isn't just something that will happen on this site at Fly Ranch, but ultimately that having these semi-permanent locations that are owned by community groups so that year-round iterations in the same template, much as we develop these technology tools, that we can get one step closer, bringing more and more people into the experience of co-creating and manifesting what will work as we reimagine and reinvent our civilization. Welcome to Fly Ranch. This is a new era for Burning Man. This is a gift from the Burning Man community as a social experiment for humankind in the 21st century. Thank you, and we'll show a video to sort of immerse you in the experience. We hope you can join us there soon. Thank you. This isn't photoshopped. This is the real geyser complex here. Here, we got the audio. Beautiful. There's currently no development whatsoever on this property. It's a blank canvas, and will stay that way for some time. Only temporary, different permutations of artistic development. Thank you.
Wow, thank you so much, Bear. Very cool. We're running like 10 minutes late, but no worries. Next up, we have Horst Zuse, and Horst Zuse is going to tell us about the origins of the computer. And yes, please welcome Horst Zuse.
So, okay. Oh, wait a moment. They are moving now, so I'm waiting in 1 minute. Should I start? Pardon me? Okay. Okay, dear ladies and gentlemen, the next 15 minutes I will talk about the origins of the computer. And my name is Horst Zuse. And to this year, we have 75 years anniversary of the first computer of the world built by Konrad Zuse, who is my father. And the next how I need to the next image I need, yeah. Okay. Here, good. Okay. Okay. This image shows me. I was there 4 years old, and I'm standing at a computer. It's a memory of a computer in '49. This image is very seldom, because at this time we had only some computers worldwide. And let's come to him. Born in Berlin, there he is 75 years old. Born in Berlin, in Wilmersdorf. The left image shows him with 6 years, with his mother and with his father. The father was a post officer. And he did like the steel constructions close to the Technik Museum here in Berlin. He went to school in Hoyerswerda in the east of Germany from 24 to 28, and there he made the final examination. That is the post office. And at this time, he did not think about to build computers. He didn't know what a computer is, because there was no computer before this time. And what he did during school time, cartoons. And that's on the left is an image where he is 16 years old. And this is a cartoon Monday morning at 8 o'clock, mathematical education. This was his view about mathematics. And that was the school, the pause in the school. And this was Rifleman's meeting in Hoyerswerda, and down with anti-feminism, and some cartoons like that. He made a lot of them, image without terms, or never should be a war again. That would be really fine. And this is his shanty. And he went to the university in 29. He started with architecture, boring. He changed to architecture, boring. Then he went away from the school, no idea about to build computers and something like that at this time. And he went to the Ford Motor Company. And there he made a lot of graphics for Ford cars. I will show you something of them, some of them. Brandenburg Gate. And this was in 32. And something like that. And this is the last one. And the parents said, you have to study. You have to study, and to finish your study, he changed again to civil engineering. And this changed his life. He had to make a lot of mathematical calculations. And then he came home in 34 to his parents, and he said to his parents, that's not important here, so, said to his parents, I did quit my job with the Henschel Aircraft Company, and I need the living room. I want to build a full automatic calculating machine. And the parents said yes. And then he started to think about such machines in 36. He said an engineer needs a calculator, computer. Everything should be done automatically. The punch tape have to be the instructions, and everything has to be executed automatically. And he started to build in 36 the Z1 here in Berlin, in Kreuzberg. He made a try, and he used metal sheets. You can see it left on the bottom, metal sheets to realize the first computer. And they started in the living room in 36 to build the first computer, the Z1, and the father did help with a York saw. And they built and built, and in 38 this machine was finished. Many people say this is the first computer of the world, but the functionality was not very reliable. It's a digital computer like our computers today. This computer was financed privately. It's very important. It was not done by the Third Reich. And then he made a reconstruction of this machine, and I will show you how it works. That was in 87. The original one was destroyed during the Second World War. And you can see the calculation unit or the arithmetic unit here. And the input and output device. This is a binary digital working machine. And yes, it does not work. It should start automatically. OK. You can see here the memory. It should start automatically. OK. This is this machine today. You can see it in the Technical Museum in Berlin. That's the Z1. Let's come to the Z3. And the Z3 started in 39, and it was here. There's only this drawing, because at this time all the images were destroyed by Allied air raids in 43. And this image right is Mietfesselstraße 7 in Berlin-Kreuzberg. And there he could present the machine in 41, May 12. And this is a reconstruction of the first machine. And this was this year, we had the 75th anniversary of this machine. What is it? It is really a computer. It's programmable, it's digital, it's a binary number system with floating point numbers, and rebuilt in 61. And 1 second around addition takes around 1 second, a multiplication 3 seconds. And here are some topics: binary floating point computer, binary memory, Boolean logic. He did not know it, he invented it by himself. Freely programmable with a punch tape, and input-output devices with decimal floating point numbers. And relays and stepwise relays were the elements which were in this machine. And there should be a movie. That's the Ries Kontakten in Munich. Good. Input and output device in the decimal system. And this is the Ries construction done by me in 2010. You can see it here in the Technical Museum here in Berlin. It's the original size. And I did it to explain the people the easy question, what is a computer? The answer is much more complicated. And some slides, then I will finish. Then, 1949, he founded a computer company. This is the first computer company in a very small village close to Fulda with 3 people. Later, in 1964, he had 1,200 employees. And he built with this company more than 850 computers during this time. And this I cannot show. Then he developed a drawing machine, because if you look in mathematical books, you have everything, you have drawings. And the last 2 slides. In 1995, he met Bill Gates. And Bill Gates wanted to know him, and they talked to each other. Bill Gates acknowledged what Konrad Zuse did. Konrad Zuse acknowledged Microsoft and so on. Then Konrad Zuse on the right side said, Mike has said he never thought that it is possible to earn 1 cent with software. And then Bill Gates asked, why is that? And he said, Konrad Zuse said, my customers asked, if you are buying a washing machine, the manual for the service is free of charge. And at this time, it was really so that people expected free of charge software. And then he gave him this image. He was a painter too, Konrad Zuse, and this should be in this bureau of Bill Gates today in Redmonton. And the last slide of my talk, this is a conflict between him, who did build, Konrad Zuse did build the first computers, and in 1994, I can show you the conflict between Konrad Zuse and the PC, and this is a conflict between these both guys, and I thank you very much for your attention. Thank you.
Thank you, Horst Zuse.
Thank you. Thank you.
Thank you. I'm sure
Thank
we'll still see you walking around here at the TOA space, so if anybody still has questions,
Thank you.
Please find Horst then. Next up, we have Ben Larson. Ben Larson is the co-founder of Gateway, and he's going to be telling us about a brave new cannabis world. Thank you, Ben.
All right. I thought they were going to put me up here after Bear and get pigeonholed into that LSD Burning Man conversation. But no, here I am now. When Aldous Huxley wrote Brave New World, he took a bold leap into how humans would use drugs to kind of manufacture a reality for themselves. It was a very bold look. It was, 600 years into the future, 2540. I think he got some of the things wrong. It was a little dystopian for my flavor. And ever since I entered the cannabis industry, I've learned a lot about some of the truths that he was unopening in his book. And so I'm going to tell you a little bit today about how cannabis is going to influence our future. But I'm not going to go 600 years into the future. I'm only going to go to 2040. And in 2040, it's not too distant from now. We can feel it. But it's going to be vastly different than today. The knowledge that we're going to gain over the next 20 years is going to be vast. Your mornings will no longer involve heavy doses of caffeine because you'll know that taking this drug will significantly alter your body's equilibrium. And your body will no longer be able to operate at its optimal levels, and you're going to need more of this drug, and you're going to become addicted to it. And we know this is going to be the case because it's already happening. But what you will do is you'll wake up. And with your AI of choice, whether it be Siri or Alexa or whatever comes out in the next 5 years, you'll basically just ask it to do a simple diagnostic of your body, and then your own little pharmaceutical machine in your house will produce a pill. That pill will be based on your desired operating output. Whether you want to go to the gym and have the most insane workout to kick off your day, if you're going to go into the office and start hammering out that busy schedule that you have in front of you, or if you're going to play hooky for a day and come listen to some amazing speakers at TOA, it's up to you. You get to have the experience that you want. And this very same technology you'll be able to use throughout the day to have an amazing creative brainstorming session, or to relax a little bit after work, or to combat that terrible insomnia you've been fighting. This technology that is going to enable this is already here. The research is being done. The compounds exist. They have existed for many a time. And it's existed in this plant, this amazing plant. It's a very complex plant that we're just learning about, but for many, many years, there's been a stigma built around it. This amazing plant has been used in medicine, religion, and yes, for fun. But what makes this plant so amazing? That's the big question. Unfortunately, cannabis has been used as a weapon in racism, classism, sexism, and just about every other ism out there. It is so vastly available to the masses that the elite have used it to press people down. And I'm not going to be up here, spouting off as an advocate, but I will educate you a little bit. There have been very evil, often white gentlemen for some reason, that have used it to suppress the lower class or races that they just simply didn't understand. They thought that cannabis was the source of satanic music called jazz. Nixon used it to disenfranchise the hippies when he didn't like their anti-war movement because war is so good. It's been used in China throughout millennia, up to 4,000 years ago, or 5,000 years ago, I believe. In the medicine, throughout the years, it wasn't until very recently that cannabis was considered illegal. Same with India. When the colonialists came in from Berlin, that's where we are. When they came in from the UK, that's when the stigma for cannabis started being built. Ganja was a very big part of India's life. Now it's relegated to these government-controlled shops, and in just a very simple form. Mexico, the conquistadors, nope, they didn't understand what the Aztecs were smoking. I think you can understand when it became illegal in Germany, and then those evil guys in the US. This is just in the last 100 years where it became a tool to disenfranchise different groups that weren't in power. And it's really unfortunate because what has happened because of the stigma is that we haven't done the research that is necessary to really understand this plant. Now, to fully understand the history, I really recommend this book. Steve D'Angelo did a great job at summarizing kind of the history of cannabis and just opening up Pandora's box. I really don't have enough time to go through it all, so I'm just going to move on to this part, which is today. It's considered a Schedule I drug in many countries, the US, Europe, and basically anything under the UN. It puts it in the same category as ecstasy and heroin and LSD. Worse than cocaine, opium, methadone, and methamphetamines. That is insane. To hold on to the statement that there is no accepted medical use, it's just ignoring facts. But the tide is shifting. There are many legal states that are coming on board in the US. Only 4 that are adult use, so basically you could walk into a corner store called a dispensary and purchase it. The medical states, though, it's almost just as easy. In fact, it's almost as easy as calling an Uber. In fact, you can do it in an Uber, where you talk to a doctor, get your recommendation, and then you're eligible to go. It's because there are so many medical applications. Who's to say that you don't have anxiety or sleeping problems or need pain relief or a stress reliever? So it's a big year. Presidential elections going on, won't talk about that. But there are many states that might be transitioning to adult use for marijuana. Some big states, California, my home state, is on the ballot. When that happens, you're talking about a $5 billion industry in the state alone. And then there's a couple other honorable mentions coming down the line too. So all these states, not all of them are going to pass, but the voters are speaking, and these are reaching the ballots, and that's important. Because as the trend shows here, legalization is unstoppable at this point. In our age bracket, most of ours, 71% approve of legalization in the US. It's accelerating. And it's happening around the world as well. So these times, they certainly are a-changing. And as they change, science comes into play. We have learned that all of our bodies are designed with this amazing endocannabinoid system that is specifically designed to interact with the compounds in the cannabis plant. And not only our bodies, but basically any animals. People are making dog treats for dogs with anxiety, help them mellow out a little bit. Or horses that have a lame leg, just rub a nice non-psychoactive balm on it, and it goes away. It's amazing stuff. So you have these receptors all over your entire body. And that's why when you smoke, you get all these unpredictable effects. Because you have a very complicated plant that has more than just THC in it. It's 85 unique compounds in that leaf that interacts with all these receptors that are in your body. 85 compounds, all with unique effects. THC is the most well-known. That gets you the high. It also has some pain-relieving components, but it's one. There's also CBD, which is the second most prevalent, and there is no psychoactive effect. Well, that's arguable. It does put you in a restful state. It relieves some pain. It relaxes your muscles. It helps young kids with previously untreatable seizure conditions like epilepsy, this really rare called Dravet's. And now it's just coming out that CBD is available for those treatments, but it's still illegal because of its association with the cannabis plant. So people are not getting their medicine because of these illegalities that were put into place years ago. This needs to stop. Like, people need their medicine. So that's 2 of the compounds, the most well-known ones. And as things legalize, we're doing more research and finding things like CBN, which is the compound that makes you go to sleep, which some of you have probably experienced before. But if you isolate CBN, think about the opportunities to create a healthful sleeping aid that doesn't have negative side effects. Or CBG, the building block of many of the different compounds, is well known for its use in treating glaucoma because it releases pressures in the back of the eyes. There's many other applications to it as well. It's amazing stuff. But what's amazing is that that's just 4 compounds, and I don't have enough time to go through the other 81. And a lot of the research hasn't been done yet because we're just scraping the tip of the iceberg right now. But just take a moment and think about the claims you've heard about the applications of cannabis, and now think about isolating each one of these compounds and understanding how they interact with your body. And then extrapolating a little bit and understanding that when they work together, they could have unique effects, and that the consumption method also has unique effects. So the research is being done now to really not only understand how to operate with these cannabinoids, but also how to produce them in mass. Because not all 85 compounds are very prevalent in the plant, but they exist. And now people are creating methods to produce those compounds individually in mass. And there's a lot of power in there. But again, it's just going to take time and money. And as we make the plant legal, we're going to have the ability to research the crap out of it. This is one of my favorite quotes from this movie. Everyone seen The Martian? I love it. Yeah, we really are going to science the shit out of this, and it's really going to make it very powerful. And the biggest problem with cannabis is that because of all these compounds and all these different effects, it's just made it very complicated to drop it into a bucket. Is it medicine? Is it a drug? Is it a tool? Humans love to drop things in buckets, but cannabis does not fit into a bucket because it infects your entire body. But luckily, we have enough support now and enough people driving the movement that we've been able to categorize things. I run a startup incubator. We're focusing on building business. I'm not the science expert. I'm not the drug expert. I'm merely an educator. But we do have the right people pushing the boundaries now. And people are approaching it from the medical side, from the recreational side, proving that it's a lot less impactful than alcohol. And it should be free. So thinking off into the future and how fast technology is able to impact research, you can see that cannabis is going to be able to play in many different realms. It is going to grow beyond its projected $100 billion industry market cap. It does have the power to become the next internet, where when a startup exists in the industry, they don't go out claiming the size of the internet, the market potential of the internet. No one does that. And no one's going to be doing that in cannabis in 5 years. They're going to be talking about the diet pill market. They're going to be talking about sleep aid market, health and beauty, athletics, everything. And it's not that far away. The science is being done. We just need to kill the stigma that has been wrongly applied to it. And that's why I started Gateway. This is the next trillion-dollar industry. Cannabis is going to find its way into everyone's life. And it's not going to be seen as a drug. It's going to be another useful tool that we use throughout everything we do. Thank you.
Thank you, Ben. All right, so next up, we have Matteo Lai. Matteo Lai is going to be telling us about wearables in the medical field. So let's please welcome Matteo.
Thank you. Fantastic. Hi, everybody. Ben's talk was very fascinating. Actually, our company works on epilepsy, so we see a lot of treatments with cannabis. And I was joking last night that actually there's a lot of drugs that do a lot more damage, namely alcohol and sugar, that are not depicted as bad guys as cannabis. And amazingly, in epilepsy, two of the best treatments for reducing seizures in people that suffer from Dravet, as Ben was saying, there are two. One is cannabis, and the other is the ketogenic diet, which is basically a high-protein, no sugar, no carbs diet. So amazingly, no sugar makes people better, and cannabis makes people better. So you might wonder who the bad guy is, but anyway. So what I'm going to talk about is a little bit of the work that we do in the company that I'm a co-founder and CEO at. It's called Empatica. And it's not so much to pitch about the company, but it's more of an example of many things that are happening in digital health, and although more of them would be needed. So I'll start with a little story. This goes back to MIT Media Lab where this technology started. Our chief scientist, Rosalind Picard, she invented a field called affective computing, which is basically using sensors from the body to understand human emotions. Sorry, one slide forward. To study human emotions and behavioral response in daily life. So didn't do anything. So the idea was to understand what people are doing outside of the hospital. So in healthcare, we know a lot what happens in the hospital, but we don't know anything of what happens outside. And she was studying kids with autism. So these kids are nonverbal, so they cannot speak, but they wanted to understand what the stress levels were. And during one of the studies, one of the students brought two devices for winter's break, for Christmas break, and he put it on his brother. And he was measuring the two wrists, because you have different responses from the nervous system on the left and right side. And amazingly, one of the devices had a huge spike during Christmas, but the other one was quiet. So Rosalind thought that the sensor was broken. And when they look at the data, it was actually perfectly fine. And what they had found was that the kid had a seizure at home, and it wasn't unsupervised. And so from there, in sort of a serendipitous way, we started working on this technology. And the reason why we did was because today people that suffer from epilepsy have a very poor lifestyle. This is actually the state of the art. So you have an EEG strap in your body. You have no real-time detection, and it's generally pretty miserable. I mean, you cannot do anything outside of the hospital. And on top of that, epilepsy claims a lot of lives, because people that are sleeping, sometimes they have seizures, and some of these seizures are very dangerous. And so there's no way to do real-time monitoring. And these are some of the neurological diseases that are causing a lot of lives and cost to society. Actually, epilepsy doesn't get a lot of publicity. Some of the other smaller ones do, though. And so to work on this challenge, we had to work on several problems. The first one was to develop sensors. You saw in the first slide, that was actually a sweatband, so like very low tech, but it worked. Sensors that are used in daily life that have the same clinical quality as the equipment in the hospital. The second one was to use the signals to understand when people were were in a certain state, like having an epileptic attack or being stressed or having a meltdown in the case of autism. And the third challenge was to build something beautiful for these people that are suffering. So not the usual clunky medical device, but something that would be more pleasing and would make them like feel normal, like other people. So we started with the first one, and we designed a few sensors that are used today in the hospitals. They're used by all the top researchers, universities, pharma companies, a lot of people that are basically working to understand what's happening to people outside of the hospital, or in the hospital sometimes, in many different fields: neurology, cardiology, behavior, sports medicine. And this is very interesting because some of this research wasn't really possible before because you didn't have enough quality in the data to really understand what was going on. And with these devices, we used it to do a few clinical studies to validate the fact that we can see when a seizure is happening in real time using the sensors. And we designed a new product that I'm actually wearing. I use it for stress, not for epilepsy. And we called it Embrace. And we wanted to design the first medical device that could be as cool as a device that you would find in an Apple store without relinquishing the quality of the data. And so we did a lot of work to miniaturize the device. It looks very cute on the outside, but inside it was, I mean, there's a lot of blood that you don't see on the slide, but it was a very, very tough work. And so what the device does is two things primarily, and this is an example of what will be possible in many other areas of healthcare in the future. One is looking at what's happening in real time and sending an alert when it's needed. So it sees an event, it sends it to the smartphone, and then the smartphone sends an alert. The second one, which is more fascinating for the people interested in artificial intelligence among the audience, we know when an event is happening, and we also see the behavior during daily life. So we see the stress changes, sleep disruption, physical activity. We also ask when people are taking the medication. So what's happening with this is that we can build a personalized model for each patient, because epilepsy is different for everyone. It's like autism. I mean, there's no one disease, is a spectrum of many different variations. And so we can build a personalized model, as the idea is to trying to forecast when the next event is going to happen. So whereas today we do in real time, in the future we'll be able to say, hey, based on your past days of data, since you didn't sleep very well, you were stressed yesterday, you have 80% chance to getting an event in the next hours. And so this is something that we are working on at the moment. Our main interest, I'd say, is, as you can guess, is studying human behavior in daily life. You know, the human body is the most complicated machine ever built, and despite all the talks about artificial intelligence, we don't even come close of a fraction of a hundredth of the complexity of the human body. And there are still many things that we don't know. So we try to study better for the areas of chronic diseases that we're interested in, but we support a lot of other things, and these are some of the diseases that need attention to. You can see they're actually a lot bigger than epilepsy, and this is just the US, so it's a sizable amount of the population. There's other things that are not here. There's migraines, for example, there's stress, and other forms of addiction. On top of that, this is some of the work that our clients do in hospitals and universities, and these are, I mean, some of this is very experimental, some of this is more advanced, but it's a lot of research. And one thing that is sort of sad when you work in this industry is that there's not enough talented people working there. I mean, you see I don't know, like a couple of millions consumer apps that do from photo sharing to messaging to bots, and they're very cool. I mean, the amount of user experience and addictiveness and crafting that goes into that is amazing. But sadly, digital health doesn't get a lot of that, and there's a lot more work to be done. I mean, we. In our company, we get asked by a lot of different clients to do all these fascinating research projects and or even implementation projects, and we don't have the time. I mean, not because we're arrogant on anything, but just because we're a very small company. And by the way, we're hiring, so we might be able to do more in the future. But we're very small, and so when you're a small company, you need to be very focused. So you can do at best, one good thing at a time. And so it's kind of a pity to say no to a lot of these things. And I really wish that there were more talented engineers, designers, product people, marketers that would be involved in digital health. So if you, one thing that I'd like you to encourage to think about, if you're thinking about your next career move, if you think about changing, if you're studying at university, if you're looking for a great passion, consider digital health. There's, in terms of intellectual stimulation, there's all the challenges that you have in technology. You have interaction and product design, you have user interfaces, you have cybersecurity, artificial intelligence, cloud computing, IoT, you have everything. I mean, the human body is basically the most complicated setup that you can imagine. And there's still a lot of work to be done. And on top of that, one added bonus of working in digital health is that you'll be helping people that are suffering today. So there's like millions of people that are suffering around the world, and they're waiting for like new enterprises and new products to help them have a better lifestyle. Thanks a lot. We'll just go out. Yeah.
Thank you so much, Matteo. We're still waiting for our next speaker, so if you'd like to take a question, we could go for a question. If anybody has a question for Matteo, please raise your hands and I will bring a mic to you. So many questions. I found a question. All right. Run, run, run. Here you go.
Well, thanks a lot, Matteo, for your presentation. One thing that I figured while working on a health tech project with the hardware base is that it's very hard to get certifications, especially in Europe. I don't know the case in USA. How did you explore that certification option, so the CA certification, for example, for hardwares? And if a hardware or a health tech company does not get a certification, what is the other way that they can reach out in terms of research or any other methods?
Yeah, that's a good question. Actually, the certification is a big problem. And by the way, we didn't start the company wanting to do hardware. We were a data company, so like data analytics, but there was no device, so it was a challenge. I think you have two scenarios. I mean, if you're really committed, because now we're into a transition phase where many companies are starting to work on hardware as a platform for enabling other applications. Like our device, I mean, we only do epilepsy, but it can be used for many other things that we don't have the time and the interest to do. And so luckily, some things are changing, so hopefully there won't be a lot of effort needed in the hardware space. In the meantime, you have two possibilities. You either do it very in a very committed way, and it's a challenge. It's a considerable investment in the documentation and the design process. Now that CE medical regulations are changing, so it'll be even more difficult starting next year. So if you want, it's better to take certified this year rather than waiting. And FDA is equally difficult. They're trying to be more helpful, but still it's complicated. They want to make sure that the risks are not there and the people are safe. The other option is that you can test your device in a safer environment. So if you want to do clinical validation first before waiting of the medical certification, you can partner with an hospital, with a university, and have like a IRB or ethics committee approved research study, and you can test it in a safe environment. As long as you demonstrate that you have a good track record in terms of safety and risk for the patient, there's a lot of universities that are very excited to try new things.
Okay, thank you so much.
Great, thanks.
So a big round of applause to Matteo again. Thank you. Next, let me introduce Paola Antonelli to you. Paola Antonelli is the senior curator of MoMA, and she's going to tell us about design and violence. Please welcome Paola.
I have the ticket. We have the ticket. Thank you so much. Good morning, everyone. It's a pleasure to meet you all, and it's a big pleasure to be here. It's interesting when you work in a place like the Museum of Modern Art, and you're looking for your presentation, sometimes you get a little bit suspended. But we're going to get there. Sorry. Yoo-hoo. Do you think I could have my presentation?
That's very wonderful. Presentation, please. Yeah, that would be good, huh?
And the 15 minutes are going to start with my first slide, so you're going to give me. But in the meantime, I can give you a little bit of an introduction. When you work in a place like the Museum of Modern Art in New York, you get a lot of rejection. I mean, you get a lot of rejection in life in general, but as a curator of contemporary design, sometimes you are a little bit ahead of what the thinking about the art world is. So you make proposals and you get rejections. I have a necklace of rejected exhibitions that I could show in a jewelry store. And what I'm going to talk to you about today is a rejected exhibition proposal that became a WordPress site, that then became a MoMA site, that then became a book, and now is becoming an exhibition. So in true post-digital fashion, we were able to turn a rejection into what will become a show, actually at the Science Gallery in Dublin. And it has to do with the idea of violence. I'm sure that all of you are thinking of violence a lot in many different facets of your life. You're thinking of violence when it comes to the terrorism that is happening in the world right now. You're thinking of violence when it comes to the immigration crisis. You're thinking of violence when it comes to video games and women. You're thinking of violence when it comes to, very simply, working in life and living your life and encountering it every day. And of course, you counter this violence with a new type of attitude towards the world, with a new sort of behavior. But sometimes violence comes in so many different aspects that they're almost hard to recognize. And that's what the project that I would like to discuss with you today deals with. It all started about 3 weeks ago. Do you remember when the 3D printed gun project was announced? It was quite a shock to me. You know, I've always been working, yes, here we go. Thank you so much, that's wonderful. Do you have it? Perfect. So my presentation is Constrain, Hack, Annihilate, or Stun, the singular relationship between design and violence. So I was mentioning to you about 3 years ago, the 3D printed gun got announced, and I remember how stunned I was by the idea that something as benign as design and as life-changing as open source could be turned on its head and become a way for everyone to have lethal power printing at home. Lethal power for sure. And at the same time, the book by Steven Pinker, The Better Angels of Our Nature, was published. Steven Pinker is a really great scholar. He's at Harvard. I would never argue with him. But he was saying that our society is becoming less violent. So 3D printed gun, Steven Pinker, big question mark in my mind. And so I did what I usually do. I tried to understand better the relationship between violence and society today using design objects as a lens. Violence has changed tremendously. You know, war has changed. Once upon a time, soldiers were warriors. Today, they're sometimes ethnographers and anthropologists. This is a manual that enables soldiers to communicate with people all over the world using sign language almost. Weapons have changed. You know, there are non-lethal weapons that are in use right now, and this is just one of them, you know, sound weapons. Vladimir Gavro was the inventor in the 1950s, and that's what sound sonic weaponry looks like right now. So things have changed a lot. And in the meantime, designers, are they so cynical as to think that weapons can be an item of decoration? This is the horrible lamps that Philippe Starck designed a few years ago using AK-47s and other weapons for bedside table lamps, which doesn't surprise me when I see really thoughtful designers like Alessandro Mendini showing chairs burning in the mountains. Sometimes we have to kill design in order for it to be reborn and truly be helpful. There's a beautiful phrase that Victor Papanek wrote in the 1970s. he said that there are professions that are more harmful than industrial design, but only very few of them. I didn't think about it before. I always thought that design was positive and constructive, but design can be evil. And I sorted out my ideas by looking at the past. You see here George Nelson, one of the most famous designers in history, the designer of the marshmallow sofa, of the beautiful clocks that are cute and decorative and are produced by Vitra. Well, in the late 1950s, George Nelson produced a CBS video that was broadcast everywhere on how to kill people. And he said that killing people was a problem of design. Of course, there was sarcasm and subtlety behind this title, but you know what? If you watch it, and it's online on YouTube, it shows you how design can actually be an instrument for evil, for destruction, for power, and for control. I started making a list of objects that have an ambiguous relationship with violence. When I say objects, I don't mean only chairs, lamps, and devices. I also mean posters, I also mean interfaces, I mean the architecture of prisons, and I kind of organize them in this instinctive way: stun, explode, penetrate, manipulate. It's amazing what happens when you close your eyes and you start creating a taxonomy of violence. And together with my co-curator, Jamer Hunt, we set out to propose an exhibition to MoMA. MoMA turned down the exhibition. They didn't understand, or they maybe were afraid of putting this kind of non-pretty, non-positive design on display. And I understand it. It's the Museum of Modern Art. The idea of modern is synonym with progressive, with good, with constructive. So what you do when you get a rejection and you don't want to ask anybody's permission or money is you start a WordPress site. And that's what we did. Every week, we would publish a different object, and you see them here. They range from technicals, the four-wheel drives that have become synonym with guerrilla and terrorism all over the world, the refugee project that kind of maps all the refugee camps in the world, the anti-pirate water cannon, or the box cutter, which has become the symbol of 9/11, even though nobody ever knew if it was really used by the terrorists that destroyed the World Trade Center, or the stiletto heel, the 3D printed gun itself. And every time, every week, we would call in a favor. We would find somebody really famous and really friendly, somebody who loved us, to write a small essay. And the first people to say yes were William Gibson, God bless him, the most generous person in the world, the great science fiction writer, and Camille Paglia, a very well-known sociologist in the United States who chose to work on the stiletto heel. So these big names called in other favors, and only relying on our goodwill and on the goodwill of others, we created this amazing website. You see, the AK-47 was commented upon by an ex-child soldier from Sierra Leone, China Keitezi. Mountaintop removal, mining practices as violence on the earth, or female genital mutilation awareness posters. And the commenter in that case was Angélique Kidjo, the great musician from Benin, who's also an activist for women's stands in Africa and in other parts of the world. You can imagine, this project lasted a year and a half, and it really put together amazing examples. I'm going to show you here Hack Infect. You see here the work of Choka Fai, who invented a machine that forces your body to move in certain ways because of electrical impulse, so you can do a 3D printing choreography with your own body. It's like really this idea of hacking, infecting. But hacking sometimes is also hacking objects. I remember seeing all these objects, all these protests in Turkey, and I saw that protesters were spraying soap into each other's eyes. They were using the soap bottles, and only later did I realize they were actually spraying milk, which is to counteract tear gas. So that's a hacking of an object that already exists. Hacking is also taking new synthetically produced viruses and that are going to be used for cancer treatment treatment and instead hacking them to infect the president's DNA, a dystopian, almost sci-fi novel that was written by Andrew Hessel, who's the scientist at Autodesk that actually designed this particular synthetic virus. And then you have Constrain. What you see here in that picture is a non-lethal weapon. It's basically instantly solidifying foam that is used by armies. It's still under testing right now to immobilize enemies. But constraining is also prison design. And you see here on the top, design of prisons in Norway. That's the famous prisons when Anders Breivik is actually held prisoner. And below instead, a maximum security prison in the United States. The two different attitudes towards constraining and keeping out of society. And Constrain is also bonding, and it's also S&M, and in this case, it's this beautiful video and contraption by a South African designer, Leni van der Weyer. Stun. Stunning is a very simple form of violence, and you see here the speculative project by Andrew Friend, which is a contraption that enables you to feel the whole brunt of a lightning without dying. So there's just enough distance between you and the lightning so you feel it, but you're not dead. So it's about experiencing violence sometimes. And in some cases, it's absolutely functional, like an anti-pirate water cannon that has been used in the Strait near Somalia, where so much piracy is happening. Another form of violence is penetration, very simply. Doesn't get any more instinctual than that. And in this case, we studied several bullets, among them the green bullets that are currently being tested by the government of the United States. They're lead-free, so they're safe for the environment. You'll be dead, but the environment will be fine. And manipulate, control, wrestle. Many of us hear all the time about design thinking. I have some problems with it, but it's an interesting way to talk about design. Well, you might not know that the government of the United States actually applies design thinking to warfare and publishes manuals about it. And in this case, we had a really great colonel from West Point, who's also a philosopher, that wrote the essay about this piece. And female genital mutilation is another form of control and manipulation, as we well know. And what you see here is a beautiful poster by Volontaire, a company in the Netherlands, that was done for Amnesty International to raise awareness about female genital mutilation. Intimidate, the promise of death, is another way to be violent. You see here some tongue-in-cheek example, two handbags. One is, I'm gonna cut your head off, and the other one, don't even come close because I have lethal weapons in my bag. Of course, these are completely tongue-in-cheek, but instead the work of James Bridle, who goes around the world in places like Washington, D.C. or Brighton, England, and tapes on the floor the shadow of a drone to make people in the Western world feel the same feeling that somebody in Pakistan or in Afghanistan might have when they see a drone coming by, is another form of intimidation. It's not very different from what we saw before, a sensor to enable one to feel what other people feel. And of course, the ultimate form of violence, explode, annihilate visibly and completely. And you see here the work of Masoud Hassani, that is a landmine detonator that is based on his experience as a young Afghani growing up in a zone with many landmines. And you see, in this case, violence is to a good end. What is amazing amongst all these different objects is that they always have an ambiguous relationship with violence. They might look violent, but be de-violent. And in other cases, it's the opposite. The ultimate violence is, of course, the death penalty, at least to me. I've been living in the United States for 22 years. I'm a true believer in New York, and I'm a New Yorker. But every time I hear about the death violence, I cannot believe my ears. And I wanted to talk about it. Every week, we would not only publish the object and the essay, we would also ask the public a question. And it was amazing what we were able to get back in terms of answers and comments to those questions, something that we would not have been able to do in the galleries. The kind of dialogue that you can have online does not happen in a gallery. So in a way, it was better that we were rejected as an exhibition. So when it came to the box cutter, we asked people which other invisible everyday objects can become lethal weapons, and we had so many different responses. By the way, you can still go online and see all this. And you see the different questions. They were serious questions. We talked about execution. Is execution always ugly? Is euthanasia a form of violence or a form of compassion? What other secretive acts carried out on behalf of the public need to be made more visible? These are the questions that we ask ourselves in our everyday life, the questions that relate to politics, relate to globalism, relate to the troubles we're going through. It's amazing to be able to use a platform like a museum and a platform as global as the Museum of Modern Art to ask these questions. You know, the Serpentine Ramp, which is the redesign of the slaughterhouse by Temple Grandin, brought in more than 150 comments. The essay was written by Ingrid Newkirk, who's the president of PETA, and the question was, can we redesign a violent act to be more humane? That was a real debate and a really passionate one. Or when it came to euthanasia, the object is this beautiful euthanasia roller coaster. Of course, it's a speculative project designed by Julijonas Urbonas, who is a Lithuanian that worked in a roller coaster manufacturing company for 5 years, so he knows what he's talking about. And he devised a roller coaster that has spires that deprive your brain progressively of more and more oxygen until at the end of the roller coaster you're dead. So the idea is to kill yourself. It's a suicide with elation. Of course, it's provocative, and it's amazing that we got answers, for instance, by a person that had a terminal illness and that had very serious pain, who said, you know what, sometimes the real violence is not death, is the pain that you have to go through. Well, you know what, this is what I want to do in a museum. I want to talk about the death penalty. The final post was about the death penalty, and it was written by Ricky Jackson, who was held in death row in the south of the United States for 30 years before he was completely exonerated because he was innocent. And he wrote about what it means to have this sword dangling above your head all the time. Of course, MoMA in the end saw that it was a good project, decided to put it on its own website, and finally published a book which came out last year. And also from the online experience, we decided to have many different outbursts. For instance, we had 4 great Oxford-style debates. I urge you all to use this format for public speaking. It's fantastic. You take 2 great people and a motion, and you have them argue with some rules and some moderation. It turns out to be fantastic. So the 3 debates were about open source, about designing empathy, about eating animals, and then there was a 4th one about the open source internet. So the first one was based on the 3D printed gun. And as I mentioned to you, it's also interesting when you design the motion so that it's not black or white. So it was not about gun control. It was about open source. So the motion was, should we support open source in any case, even if it leads to letting people print guns at home? And the 2 arguers were, on one side, Cody Wilson, who is the designer of the 3D printed gun, who is an amazing thinker. He can really put a wall of words in front of you and quote all the philosophers in the world. But on the other side, I had Rob Walker, who's a fantastic writer who looks like a crypto-anarchist himself. So it was very interesting to see the nuances. And the debate notion was, we cannot limit open source design even when we do not support the consequences. Then we also had an audience that voted at the beginning and at the end of the debate, and the winner was not the one that had more votes. It was the one that was able to change the balance of the vote during the course of the debate. The second one had as an object prompt a menstruation machine, which is a contraption to enable men to feel what it means to have a period. It has electrodes that give you shock on the lower abdomen, so you get cramps, and you have a reservoir in the back. You're supposed to put your own blood in it, and then it gets delivered between your legs. So it's the full experience. And the debate motion was, design's potential to transcend gender boundaries is limitless. The third one was about killing animals, and it was, design can allow us to humanely include animal products in our diet. And for that particular case, what I discovered is that the vegan community is really dangerous. So we had so many calls before that I had to increase security at the museum before this. Yeah. The fourth one that I'm really, really proud of was about the internet, and the two debaters were Larry Lessig and Biella Coleman. And the debate motion was, internet freedom and digital privacy will come about only through the design of better tools for civil disobedience and direct action. See the ambiguity? Larry Lessig, who believes in the open internet, argued against this motion because he believes that even if our government is really, really failing and weak, still we need to legislate and to believe in a civil society. And Biella Coleman, who is actually the biographer between quotes of Anonymous and a wonderful scholar, argued for. As I mentioned to you, this project, which started out completely digital, will become an exhibition at the Science Gallery in Dublin in September. And this is something that we offer to everyone for elaboration, for continuation. It's in the open. It's open source, as violence is. And only by acting and thinking about it as a community will we ever be able to do something about it. Thank you very much.
Thank you so much, Paola. I will take your clicker. Thank you. So we're back on schedule, which is awesome. Next up, we have Neeraj Janji. Neeraj Janji is the founder of Tinker, and he's going to tell us how he created the world's first mobile social network. First mobile social network, that way. Thank you. Warm welcome to Neeraj.
Do I need this for the slides? Yes. Yeah, okay. And the back. What is this black button?
Let's not press it.
Next. Okay.
And,
Hi, guys. Can you hear me? Okay. I got a lot of bright lights. It's my first time in this amazing studio. Thanks for welcoming me to Berlin. All right, so this is my topic. I'm Neeraj, born in India, lived in Japan, and now kind of a little bit of a world citizen, spent quite some time in Palo Alto, so that's who I am. My claim to fame is I created the world's first mobile social network. In fact, that invention is used by up to 2 billion people today. Most of you use some kind of social media, like Facebook, Twitter, LinkedIn. You use status updates. You check into locations. These were things that Imahima, the company I started, pioneered. And eventually, Facebook acquired much of the IP in 2013. So as much as the story is big, to me, it's part of my life. It's relatively unknown. And I'm happy to share a little bit of that with you. So before I go further, how many of you are above 40? So I can relate to, maybe you can have a show of hands. OK, hardly anyone. OK. So maybe this is interesting, because this is not the future. This is the history. This is the history of how mobile internet started. And so let's go through it. I have a clicking issue. OK, here we go. So we are familiar with emoji. I suppose most of us know that emoji is a Japanese word. And A is a picture, emoji is a character, so it's a pictogram. So I guess I just want you to relate to the fact that a lot of the mobile sort of things that we use today originated partly in Japan. Well, it started in Scandinavia, right, with the Nokia and Ericssons. Then the Japanese were the first ones to kind of put the internet in it. It was a platform called the iMode. Maybe you've never heard of it, back in 1999. So I was in Tokyo. This is how the iMode looked. It was a flip phone. Now they call it, maybe they call it as a feature phone today. It was very advanced at that time. You were able to browse the internet and receive mobile email. That's pretty much what it did. There was no color screen, no touch screen, no GPS, no cameras, and all these sensors and everything that we take for granted right now were not there. And then came that day. So it was around June 1999, I was walking in my neighborhood in Tokyo on a Saturday afternoon looking to get lunch. And I had my phone, my watch, and my wallet as I walked around, and I saw an amazing rush of people near a neighborhood train station. There were almost like 3 train stations, and there was like hundreds of people coming out, lots of Japanese people. And I kind of stopped walking, and I thought, wait a minute, maybe this phone that knows my location, it's a cell phone, cellular technology, it kind of knows where I am, it knows where to call me, it knows where my friends are. Why doesn't it tell me? And I didn't want to have lunch alone, so I really thought this would be useful. I took the phone, put it back in my pocket, and that was the epiphany that changed my life and probably touched the life of hundreds of millions of users after that. I thought about it. I thought it was kind of obvious. I thought that the cell phone company would do that, but maybe it'll take them a while. So I thought I might ask for the location data from them, but they wouldn't give it to me. I was, again, just a mere Indian in Tokyo. So I came up with a different way. I came up with a way where we call this self-declaration, that you would announce your location. And it was not just your location, your activity, your mood. In fact, you guys do that every day now. And this is how I defined it. Ima Hima. So Ima is now, Hima is are you free? So it said in the patent application that it's an internet-based communication service for users of smartphones, which was a new word then, enabling them to exchange information about current personal status. So I coined the word status update. And the status would be your activity, whereabouts, and then you could share it privately and publicly. So this was a drawing showing on the left. You can see some of my friends, their names, and some kind of messages where they are, what they're doing. And I thought it would be pretty handy on a Saturday morning when you don't know what to do next. So that became this service, which went live in December 1999. And there were only 1 million internet phones at that time. So just think about it. We almost are at 2 billion today. And most of my friends didn't have this kind of phone, so I couldn't really use it with them. So we had to create what I call the public mode, that you could share it with people who had the phone, doesn't necessarily be someone who's a friend of yours. So now on Facebook, for example, when you do a status update, you choose location, you attach a photo, and you can say, show it to my friends, or show it to everyone. And that's the same or similar concept. So that is the news feed in its first form, which is basically Tim, Rika, someone is at office, working overtime, and so on. And this is actually never shown to public before. So this is the entire sitemap of the world's first mobile social network. Later on, I don't know if the content would be distributed, but I think it belongs in a museum, in my humble opinion. But back then, it was pretty simple. The green screens are the ones you see on your phone. The blue ones are emails that you get. That's the only way for us to send notifications. The email would have a link, and the link would bring you back to a simple website. So how would it really work? Well, you would take it out and try to see if someone's nearby. So you would log into the website, and the web will ask you to update your status first, because it would expire every 4 hours. So you would update your status, and then see the feed that you saw a little earlier. And if you updated your status, all your friends would get these mobile notifications, which was just an email. Their phone would ring, they would take it out, and the link would try to bring them back to the site, and at that point, they would update their status, and then it would go on and on. So that's about the site. This was an office around 2000. And, well, we made some news. In fact, in Austria, we got the Net Excellence Award back in 2001. And if you're really interested more in the history of this story, you can go on YouTube and look at Ima Hima. Again, it's very unknown, so you'll find it a little surprising, I hope a little surprising as much as I find it. It is right now. Well, then what happened with my life is we fast forward to 2007 and 2008, and well, iPhone came along, which was an after iPod, and then a year later, Android came along. And the entire mobile ecosystem shifted from Japan to Silicon Valley. And over the next few years, you would see the big players like Facebook, Twitter, et cetera, go deeper and deeper into mobile phones as we use them now. And so I felt that I needed to be somewhere else and no longer in Japan, so I left in 2009. And 2013, Facebook acquired much of this IP, setting me free to work on new ventures. I started a company called Tinker, and it's based in Singapore and Palo Alto. And I'm just about to launch a new product called AirMount. It's my attempt. It's a project that deals with the idea of sharing with content nearby. So like all of us are here, if I want to send a photo to you, why do I have to send it all the way to the internet and back? Why couldn't I give it to her right now? So this is something that I explore in my next project. It'll be out later this month. Do check it out. And I'm open to any questions. Thank you so much.
Thank you, Neeraj. We have time for one question. So hands up. Yes, I found a question.
Speaking of sending it to me, is it like, can I imagine it as AirDrop?
Yes, but AirDrop is very droppy, so I feel
or
a
like
lot.
Bluetooth?
Bluetooth is really slow for sending large, big photos and videos. So, and there's other problems with it. So if I just send you a file through one of those means, it'll be kind of in your downloads or wherever. It'll lose its context. So I want to be able to give you the context the way it was, and I want to make sure that you can interact back and forth with the content without creating additional copies. So that's the idea. You don't need to use Wi-Fi. You can use it in a submarine, an airplane, a remote, wild outdoors. It'll work all the time. I can show you a private demo later, if you like.
But I guess they still have a little bit.
Well,
we can take one more question, actually. Ooh, there's a question. OK. Do you want to scream or? Nah, let's not scream. I'll bring the technology to you. Oh, oh. There you go. Of course.
Why didn't the social network blew up like Facebook?
I couldn't follow you, please.
Why didn't your social network blew up like Facebook?
Yes. Sometimes we want to be on the leading edge, and it might be the bleeding edge. And I think that's a little bit that I was ahead of my time. In 1999, that was a time we didn't even have high-speed 3G networks, let alone this unlimited data usage, these easy-to-use smartphones, the App Store model. The generation was still struggling with the idea of, isn't it private information about where I am, my photos? So I think the world wasn't ready for Ima-Hima when it came out. It took almost a decade before that happened, but I'd already run my race, and I had a choice to move to Silicon Valley and start all over again, which is something I considered. But you know how you feel as a marathon runner, you've already given it the best. I knew it would take over the world, but I'd really spent all my energy, and I wanted to move on to something else. So the new vanguards, the new players, and it often happens, the pioneers are not necessarily the ones who dominate and become the leaders of the industry. So I was happy to see my inventions go to Facebook because they can really take them forward, although I will reserve my comments about what it has become and where it'll go.
Cool, thanks so much, Neeraj.
Thank you.
Yeah, let's move the couch aside. Next up, we have a fireside chat with Dominik Richter from HelloFresh, the CEO and founder. And the moderator will be Robert Waters. I'm sorry if I'm pronouncing your name wrong. Founding editor of TechEU. We're going to set up the couches, and then, yeah, you can start and have a wonderful chat.
Yeah, water would be awesome. That's fine. Hi, good afternoon. We're actually starting a little bit early, which is kind of unusual for conferences. So my name's Robin. I'm a journalist. I run a website called tech.eu, so I write about the European tech scene. I'm joined by Dominik Richter, who's one of the founders and the CEO of HelloFresh, which I'm sure, especially here in Berlin, doesn't really need an introduction. But I'm still going to ask you for one. What's HelloFresh? What do you do?
So I'm Dominik, entrepreneur. Started a company called HelloFresh 4.5 years ago. So with HelloFresh, the vision that we have is to really make home cooking accessible and to say that if you are someone who can commit to cooking at home, we want to make it as easy, as accessible for you to actually do that and basically take all the hassle out of it. And I think on a, let's say, grander scale of things, what we're really into is basically making sure that we can provide people with healthier alternatives than what they would usually choose for. So the way that it works right now is basically you subscribe to a plan, and then once per week, we'll deliver a box with pre-portioned, super fresh ingredients to your doorstep so that you can basically cook a number of meals in 30 minutes, 40 minutes, and have a delicious and nutritious dinner on the table.
Gotcha. So it's a meal kit delivery service that works on a subscription model. The fact that you choose overall mostly healthy ingredients, is that part of your mission, or is it just because the customers demand that?
So I think first of all, if you look at the kind of ingredients that we send, it's never processed food. It's always like fresh food. And I think for like 90% of the people, that's already like the healthier alternative than what they would usually choose. And I do think that there is certainly like a big mega trend going on, which is people are way more conscious about what they eat, way more conscious kind of like where the stuff stems from. And we actually, with the model that we pursue, have the opportunity to make it very transparent. Where are your tomatoes from? Where are the potatoes from? Where is each and every single ingredient from? We're not yet doing like a super great job in always kind of like letting you track back, but we're actually doing an awesome job in picking the right suppliers, auditing our suppliers, and in the future, I think you'll also see a lot more of kind of like that layer of transparency that will get it across through our blog, through our recipe cards, through all the content that we basically create.
Got it. You mentioned your suppliers. Who are your suppliers of these ingredients? Is it local farmers? Is it mass distribution centers? Is it the same suppliers that supply the big supermarkets? Where do you source your ingredients from?
It's a big bunch of suppliers. I think it also has changed a lot over the 4.5 years that we've been active. So I think in the very beginning, for us, the most important thing was really to minimize complexity while obviously like meeting certain quality thresholds. But we were mostly buying, let's say, wholesale, etc. in the beginning. And then over time, as we have scaled and we have like much more volume, we've been, we have started to build out our own procurement departments. And now what we're doing for each of the categories, like meats, dairy, produce, fruit, veg, we always have a certain, let's say, bunch of suppliers that we've audited, that fulfill certain quality standards, etc., that we're regularly visiting. And across those who we have onboarded, we basically spread out the orders that we have per week. And I would say at the moment, it's like about 50-50 between directly producers and wholesale. But certainly the ambition is to, hopefully at one point, like go even further in the value chain and actually say, like, maybe we can grow our own stuff.
Right. Great. So the good thing about your model, I guess, is because it's food, it means it's not a luxury product. Everyone needs to eat. Would you say you compete against restaurants or takeaway ordering sites, or do you compete against supermarkets where people go to buy their own ingredients and recipes?
Yeah, I think it's a good question because there's obviously there is a bunch of let's say, directly competitive services that also offer meal kits, but in the end, that's not so much what we're looking at. The kind of framework that we tend to apply when we think about our market and when we think about our customer segments is really to say, people eat about 90 meals per month, and everyone subconsciously sort of makes a decision how to allocate their food budget. And you might do takeaway once or twice a week, you might go to a restaurant, you go to the supermarket for some certain meal occasions, and hopefully, you also do 3 or 4 meals per week with HelloFresh. So what we really focused on is to have a great value proposition for weeknight dinners. That's kind of like at the moment what we're focusing on. But overall, what we really see as our market is to say, out of those 90 meals, at some point, for how many can we as HelloFresh deliver you with all the stuff that you need to actually, follow a healthy and sustainable lifestyle.
Right. As you scaled up the company, the distribution of the actual packages that you deliver to customers directly, does that happen in centers that you rent? Is it your own fulfillment centers? Or how has that evolved over time in the last 5 years?
So again, I think obviously very rapid progress over the last 4.5 years. In the beginning, we did everything ourselves, basically packed it in the back of our offices, then had our very first small fulfillment center. At some point, when we were going through a big phase of growth, we actually said, let's reach out to fulfillment partners who can help us scale. Because if you're in that massive growth phase, it's very, very hard to actually figure out how big a fulfillment center do you need. How big will you be in 6 months, in 9 months, and 12 months? And at the same time, you're also resource constrained because you don't have unlimited funding. You actually need to always kind of like, make sure you have as much runway as possible. Hence, for us, the best solution in that phase of growth was really to say, we have a third-party company that we pay on a, let's say, per fulfilled box basis, and we can scale up with them. And then basically, once we saw that consumer demand is very strong, that this is a category that's, that's here to stay, that's not gonna go away, and that's still growing fast, at some point we said, okay, over the long run, it's strategically very important that we own it, so that we can innovate, that we can really make sure we apply the right care and the appropriate care to all the processes. And that's basically when we made the decision to invest in our own fulfillment centers. And right now we have 12 fulfillment centers globally, of which I think 7 or 8 we operate ourselves, and the others with third-party partners. And I think, thinking 5 years out, it's probably a part of the supply chain that we want to fully own and control.
Right. So in time, you might be a partner for other service providers that use your warehouse kind of as a fulfillment partner as well, or not?
I mean, it's not top of our agenda to become a fulfillment partner. I think generally, like the way that we see HelloFresh and what we're really concerned with is to say we want to build up HelloFresh in a really well-liked food brand, and not so much kind of like go into, let's say, white labeling for other partners or fulfilling for other partners. That's at least at the moment like nothing that's on our agenda.
Got it.
But I think, on a theoretical basis, we'd probably have the capabilities to do something like that.
Very interesting. I'm going to ask you a series of questions that you need to answer with a number. How many countries are you operating today?
As of today, 9.
9. How many employees?
Around 1,200.
How much funding raised?
Roughly 300 million.
Euros or dollars?
Euros.
It's euros. How many packages do you deliver per month?
Last public figure that we published was 8 million meals per month.
8 million meals, up from how many last year around this time? What's the percentage growth, roughly?
Last year, so in the first quarter, we grew 200% year on year. So, given that, we had about, let's say, 3 million meals last year.
That's quite impressive. Yeah, you mentioned 300 million raised. Obviously, because you have your own fulfillment center and you employ 1,200 people, it's a pretty capital-intensive business. How close are you to reaching break-even or profitability even?
So traditionally, we've actually been a very capital-efficient business. So for a very long time, we actually consumed very little cash, and we had been at a point where we were basically break-even across the whole company, and then made the conscious decision to say we want to invest more because we think long-term, kind of like over a 3-year horizon, that's really kind of like what's the best for the company. And that's when we raised like large parts of the kind of like, and the more recent funding rounds, to really put that into building out our infrastructure. So generally speaking, we are in a position where we can very much control if we want to push for growth and grow 200, 250% year on year, or if we want to kind of like grow more pedestrian and actually say, you know, we're happy with 50%, 70% growth per year, and then we're very close to profitability. So as of now, out of the 9 geographies, we have 2 who have been profitable for a very long time, and another 2 or so which are kind of like on the brink of profitability.
Got it. One thing I didn't know that you mentioned in the conversation we had just before this session was that the US is actually your biggest market already. And you only launched there about 18 months ago. So tell us
so
how
we
that happened.
soft launched in the US about 2.5 to 3 years ago. Kind of like kept it very small, tried to verify all the hypotheses that we had and all the learnings that we made on the European market. And then about, I think it was in September 2014, again, made the decision to really expand to the US nationwide, opened up 2 more fulfillment centers. And ever since September 2014, we're basically active nationwide in the US. And since that time, have grown to like a very high 3-digit million run rate. In that kind of like 18 months time span.
But then most of the other markets that you operate in are in Europe. You're still headquartered in Berlin. So do you find it hard as you scale the company to find the talent that's required to grow a company to that size and to grow as fast as you are?
I mean, for us, we started the company in Berlin. We're, in a way, a fairly decentralized company because I think food is something which is very local. Taste is very local, and also the supply chains that we need to build up and that we need to rely on are very local. So there is a certain number of functions that we do from Berlin. So for example, all of our engineering is in Berlin, all of our analytics is in Berlin, but when it comes to running supply chains, culinary, etc., that's fairly spread out. So apart from the 12 fulfillment centers that we have another 9 offices, so it's like over 20 locations. So in that sense, Berlin is still home and Berlin is headquarter, but I myself and my co-founders and the senior management team members are actually like traveling around a lot and really making sure that we can kind of like build a global company and sustain like a global company culture.
Right. I want to get deeper into that because I'm always interested in the way that companies, scaling comes with different challenges. It's capital, it's whether it's opening offices, new markets that have different specifics, which you already mentioned. But it's also the company culture that you mentioned that I think is very important. How do you maintain that? Like with 1,200 people, it's obviously changed quite a bit since you started. So how do you cope with that as the founder?
So I think, first of all, I'm a strong believer in, let's say, leading by example. So I think it's really important that, like we as a senior management team, but also kind of like cascading down through the organization, that you really kind of like have leaders that, are basically a good example to all the people that work for them. And what I mean by that is, starts with like being on time, being punctual, being there for performance management reviews, all of these things. And I think that's a company culture that we've implemented very early on. And we actually also still have a lot of people that have been with us for 3 years, 4 years, etc. So people that basically live and breathe HelloFresh and that have risen through the ranks over the years and which have very much ingrained that culture. And I think, and that's also what we're trying to teach them, to basically, that they are those kind of culture carriers and that they need to pass on the, let's say, what we define as our unique HelloFresh culture and our set of values. In the end, like culture, the way I define it, is basically the set of values that kind of like, that basically is responsible for how you treat each other, how you interact with each other, and basically it's the kind of like implicit set of values that you have in the company that without having to state it, everybody follows subconsciously. Right. And that really kind of like, I would say, cascades down through the organization, starting from the leaders and then kind of like making people aware that subconsciously people follow other people.
Gotcha. Okay. On the flip side, any mistakes that you've made that you want to tell entrepreneurs not to make?
I think there is mistakes that we have every week. I think generally on a company level, like a lot of things have happened when we were still fairly small. I think in the end, the kind of approach that most companies have is there is 1,000 things to do. So in the end, if you start out and if you're growing fast, then you kind of like tend to break things and things tend to break down. But then if something breaks down, it's actually the kind of like impulse to say, hey, let's spend some time on this, let's fix it, and let's make sure that we take into consideration all the other things that could go wrong, and let's find a process so that it doesn't happen again. And that's kind of like how over time you hopefully get better. But like I said, we're still like making a lot of mistakes, both on a personal level as well as on a company level. But hopefully the mistakes get smaller and smaller in scope.
Right. And you're still around, so not that bad a mistake yet. So it's very hard to talk about HelloFresh without talking about Rocket Internet. They were one of your first investors. They've joined later rounds of investments as well, to the point they're now a majority shareholder. But also because Rocket Internet is so invested in the food delivery space in general, obviously owning Delivery Hero and other companies. Do you find the relationship with Rocket has brought you a lot of benefits in terms of, they've proven that they can scale companies, they know a lot about performance marketing because they've built so many different companies in different regions. Do you find that relationship beneficial, or do you not get any advantages out of it?
So I think first of all we're HelloFresh, and I think everything from fundraising to company culture to how we deal, how we kind of like think about the business is very much centric on HelloFresh. But generally, like I would say, they're obviously very experienced investor very, very early on in the company, and have supported us throughout the life cycle so far. So for us, the relationship has been very fruitful. But in the end, like we're very much focused on what we as HelloFresh stand for, how we want to build up our brand, etc., and not so much attached to, let's say, is this Rocket, is this not Rocket, is this another investor, etc.
Sure. What about the IPO? 2016 or 2017?
Again, I think for us, the kind of like vision that we have for the company doesn't really change whether we do an IPO or not. I think what we would find very hard at this stage is selling the company to someone, because in the end we've come so far over such a short amount of time, and we still have so much that we want to do that we're not really interested in selling to someone else and basically say, hey, that's it. So in that sense, for us, an IPO is obviously very attractive. But if that is in 6 months, 18 months, 24 months, that's nothing that kind of like changes our strategy for the longer run. We are well capitalized, still have a lot of cash on the balance sheet, so we don't have to do one. If there is like a great opportunity to do one, then certainly at some point, this is, let's say, our preferred avenue to go down.
Got it. What are some of the markets that you're looking at launching next? You mentioned 9 countries now. Probably going to scale that up to a few more. But what are some of the regions that you're looking at? Is it other countries in Europe? Is it Southeast Asia? Is it Latin America? Or do you really want to focus on the markets that you have now?
So we've recently launched 2 more markets, which were basically within, let's say, the geographic footprint that we've mostly been in for quite a long time. So we've launched Switzerland to basically cover, more of continental Europe, and we've launched Canada to basically cover all of North America. And with those 2, we've kind of like covered our bases in the, let's say, broader geographies that we've already been in. I think, I'm not saying we won't expand any further, but for us, definitely the, let's say, majority of growth is really where kind of like in our existing markets, because we cover the most mature and the largest e-commerce markets worldwide. And if you look at how HelloFresh looked like kind of like 4 years ago, what it looks like today, and kind of like try to triangulate that with what do we actually want to build up and how do we want to build it up, then there's still so much that we can do in those markets that the bulk of growth will certainly come from the existing markets. And that's also where we're mostly focused on.
Sure. A little bit of a different question. You've partnered with Jamie Oliver, who's arguably one of the most famous chefs in the world. What does that partnership look like, and how has it helped you scale the business?
So it's actually a partnership that we've been talking to Jamie and his folks for quite some time. So in the beginning, we were like thinking, hey, can we do like, can you make some meals for us? Can we bridge in some way how, let's say, what you do in terms of educating people about healthy cuisine, about cooking, about, becoming a chef. And at some point, during our talks, we actually said, like, why not make that a longer lasting relationship why not kind of like trying to cover different bases with that? And by now, we're basically using him for PR, communications, and some marketing. But mostly, he and his team are creating recipes for each of our geographies, 1 recipe per week. So among the menu of the week, there's always 1 recipe created by Jamie, and that is usually supported by some content, such as kitchen tips, such as certain advice, etc., linking to some of his videos. And that's kind of like, in broad terms, the kind of like scope of the partnership so far.
Got it. Well, I assume it's been successful because you've prolonged it and deepened the partnership. Do you see any other partnerships of that sort with other people in the future?
So what we have done at some points was basically we called it guest chef series. So we basically went out to interesting chefs, interesting restaurants, said, you know what, how about you create a recipe for us? We introduce you to our group of customers. We make a nice video in your kitchen. We kind of like talk about you. We kind of like introduce you to all of our consumers. And wouldn't it be great if next week 500,000 people are actually cooking the meal that you have created? Met like an impressive response from all the people that we spoke to, and I think it's like a great tool for us. The funny thing was actually that a lot of our customers told us after, like, it's been great content and we enjoyed reading about the chefs, etc. But the way that, you know, the recipes that you as HelloFresh create, I actually like them better. And that's something that, kind of like also helped us understand that it's not so much about, you know, getting as many testimonials, etc. in. It's really making sure that you understand what customers want, really making sure you kind of like make sense of all the data that you get, because we ask people, right? We ask people, how did you like the meals? What did you like about it? What was the cooking time? The number of ingredients, the complexity, the accuracy of description. So those are all variables that our culinary teams are basically have now experience for 4.5 years on. And what we tend to find is that the recipes that we create, design ourselves, and then goes through all that testing process that we have with internal people testing it, external customer panels testing it, etc., that this process actually helps us usually deliver recipes that score much better than recipes from other testimonials, etc. So in that sense, we're very much focused in really building up the HelloFresh brand as HelloFresh, and not so much looking into, let's say, getting other people to do stuff for us.
Right, interesting. That's good feedback, for sure. From your customers. So I live in Belgium. I've had people come to my door to ask if I want to try out HelloFresh, which I've done a few times, just to reassure you. But some people don't necessarily like the fact that you're relatively aggressive marketing. And I was reading up on HelloFresh in preparation for this chat, and one of the things that comes up most is that it's aggressive marketing and hard to cancel. Would you agree with that statement, or do you think that's something that you've solved over time? Or would you completely disagree with that notion?
So I think there's certainly been, let's say, some periods of time where we've basically probably been over-enthusiastic because we've seen like great response to certain marketing channels, etc. And had been very successful in scaling up the company. So I would say, there might have been 1 or 2 occasions where we probably like overstepped a little bit, where we also had like external marketing partners which were basically pushing a little too hard because they were working on commission for us and those kind of things. So I think those are things that over time we have fixed, and where I believe that now we're like in a very good place. And with regard to cancellation, I like strongly disagree. I think we make it super easy for you to tell us when you want to go on pause, if you want to cancel, etc., etc. So I think that is actually something where, like I said, strongly disagree.
Sure, okay. On a slightly broader level, if you look at the food delivery space, I know you're super focused on HelloFresh and your model, but if you look at all the takeaway.coms of this world, the Just Eats, the Take It Easy, Deliveroo, how do you see that playing out? Like, is there going to be a wave of consolidation in this industry, or do you see all of them growing?
I think, again, going back to the framework that I introduced before, basically saying people eat 90 meals per month, then if you look, how many meals do we actually cater to at the moment for a good customer, probably like 10 meals out of those 90. It's not mutually exclusive to using other food delivery services. So I think that, with the advance of technology, there is actually now is the time that a lot of those businesses make sense for the very first time in history. And I think that's actually where you see and will continue to see a lot of innovation, because food is just like, such a big part of everyday life. It's the biggest category of household spend. So it just makes sense for good entrepreneurs to think about, what can I do in the food space? It's the biggest category, almost not online penetrated so far. So, only if you say today about 1% of grocery sales happen online, then, just moving from 1% to 2% actually is a market that is a couple of tens of billions of dollars. So, which obviously should give plenty of opportunity for great models to exist and sustain.
Right. What are your thoughts on the last mile delivery? Because obviously for you that makes a lot of difference if that changes that dynamic. I read somewhere that 80% of the cost of delivering any package, whether it's food or anything else, 80% of it of the cost is actually in the last mile. So you have this, Amazon's trying out with drones. You have other companies in Europe building these self-driving delivery robots that actually take packages up to your doorstep. Are you watching this whole evolution? What do you make of it?
So I think, again, it's definitely a space that we're watching closely. And obviously, we need to get our meals to the customer. So we are very reliant on different logistics partners. We, in parts, do it ourselves as well. So in Benelux, in the UK, we have our own fleet of vehicles, which we use to deliver our packages. Generally, I think it's also one of those areas which has only started to innovate over the last couple of years. I think the iPhone kind of like made its debut in Germany in 2009. So, pre-iPhone times, pre-smartphone times, nobody could, or like an Uber couldn't even have existed. Like a lot of the logistics tracking solutions couldn't even have existed. So I think generally we're very, very early in the kind of like whole evolution of that space. Obviously, there seems to be some winners already, but I still think that, especially in the B2B space and in the overall logistics space, there will be more and more services advancing. We're watching it very closely. We still haven't decided whether this is one part of the value chain that we eventually want to own or not. Given that there is so much innovation going on, I tend to say it's probably something that others can do better if they're fully focused on, running that rather than also a marketing company, a culinary company, a food company, and a logistics company.
Good. I don't have a timer, so I'm just going to keep going until they drag me off stage. So again, on the broader level, you're focused on HelloFresh, but if you look at Berlin, because you're not from Berlin originally, we came here about 5 years ago when you started the company. How have you seen the startup scene locally evolve over the last 5 years? Because to me, from an observer standpoint, it's changed quite a bit. But I wonder what it's like for you on the inside.
I mean, I fully agree. When I came to Berlin and before starting HelloFresh, we've kind of like played around with the different business ideas, kind of like tried to reach out to the business angel scene, tried to kind of like speak to different funds, etc. And if I look back at the kind of like list I created back then it was basically 20 people on that list. And this was the whole ecosystem back then. If you look at it today with, you have first exits that have happened and a lot of kind of like angels, a lot of people not necessarily giving back to the community. Obviously, they have some monetary incentives to do so, but kind of like building up that ecosystem, just a lot more pots of money that want to invest in startups, that want to invest in technology. And I think the situation has changed dramatically and fundamentally. I think today, if you are a good founder team with a good idea, then it actually has never been as easy to find funding in Berlin as it has been today. And I think that with more and more companies also emerging out of Berlin, that it's just the start of a scene that's actually coming. So I think almost any time in the last couple of years, when you have seen a successful exit in the Berlin ecosystem, most of these founders actually then, start to invest themselves. And I think that over the past years, a lot of companies have been started, which will eventually become very successful. And I believe that, those founders will actually follow the steps that their successors have done and kind of like also deploy a lot of the money, a lot of the proceeds that they made with their ventures back into the ecosystem.
Yeah, fully agreed. Early days of a very interesting cycle. Final question, do you think you could have built this company anywhere, or did it need to be in Berlin?
Good question. Never really thought about that. I think, so there's certainly like a number of big advantages that you have in Berlin, like access to talent, access to, let's say, fairly cheap living costs, etc., to start up with. I think there's a number of startup hubs, which probably it doesn't make a huge difference whether you are starting a company in, let's say, London, at least pre-Brexit, Berlin, Stockholm, etc. But I certainly believe in the kind of network effects and access to talent pools that you have in startup hubs. So I think you have a much, much harder time to build a successful company if you do it, let's say, in Germany outside of Berlin. That I definitely believe in. So I think Berlin is certainly among the top 2 or 3 startup hubs in Europe. And we probably could have also built the company in one of the other 2 startup hubs, but not anywhere else.
Got it. Okay. Thank you very much, Dominic, for joining us and for supporting TOA in the first place. And hope to see you around today.
Thanks, Robin.
Thank you. Well done.
So we're actually on lunch break now. We'll be back at 2 with more talks, and I unfortunately have to kick you out. So yes, please slowly start going that way and come back at 2. Thank you.